I would like to extend a very warm welcome and a pleasant evening to everyone present here. Welcome to our final day of our Mint Summit. Our title for today is Technical Issues and Mobility Solutions. Before we start today's session, I would like to invite Dr. Ramakrishna Srinivasan, CEO, Mint Collaborative, to summarize about day one virtually. Over to you, sir.
Hi, good evening to everybody. Yesterday started out very, very nicely. We had a wonderful welcome address by our Dean Mahesh, followed by the formal launch of the Mint logo and the reveal of the website and who are the founding members. And I think you can see on the screen the video playing of the actual launch, and you will see that also hosted on our website. Okay, this is a truly great, inspiring chief guest address by Dr. Neeraj Mittal, who is the Department of Telecommunications Secretary. And he actually kind of talked about many government projects, advances in 6G, the Gati Shakti, ULIP, so on and so forth. And there was real commitment to supporting this initiative, not only from him, but later on, but from Mr. Arikar from the DPIIT as well. So it was all in all with great participation from the government. And it was wonderful to see the 7 founding members, very diverse, right from people working in underwater drones to working on automotive components, logistics, and data sciences. And it was wonderful to see their enthusiasm and also the highlight of the scope and reach of what Mint's work can actually do. And we had a very, very good panel discussion led by Mr. Ariwar, who is the Deputy Secretary of DPIIT, very enthusiastic with a lot of renowned experts in looking at SDG goals and how mobility should be looked at. And, they highlighted a few things in that India is already a leader in solving mobility problems. And we don't need to actually look and wait for the global north to actually provide the solutions. A lot of things that are actually created and solved here can help address not only India's problems, but the world's problems. There was a gentle nudge that we should definitely look at more sustainable and equitable digital public goods, especially focused on rural areas as well. And we also had a good discussion on the interface of SDG and smart cities. How do we kind of, enable a 10-minute city, for instance, right? And we also heard a lot about the experiments being done by Kumta in Chennai city itself in terms of how to take a congested, already mature city and kind of make it modern from a mobility perspective. So all in all, it was a wonderful panel discussion, which kind of laid out what might be the broad themes that we need to look at. And of course, as the white paper comes out, those will be elaborated and, will set the kind of agenda and steer the Mint Collaborative towards where we need to go. And I think today's discussions also promise to be very exciting. So I'll hand it back to the moderator to kind of get us through the next program on the agenda. So back to you, Miriam. So let's get going with the day.
Thank you, sir. Let us commence day 2 with a fireside chat. I would like to call Professor Geeta Krishnan Ramadurai, faculty in charge, Mint Collaborative. He will be a moderator for this session. Our panelists will join us virtually for this fireside chat. With great pleasure, I would like to welcome Professor Chandra Bhatt from the University of Texas, Austin, and Professor Hari Balakrishnan from the Massachusetts Institute of Technology. Over to you, sir.
Thanks a lot, Miriam. And again, I welcome all of you for day 2 of the inaugural Mobility Summit. So couple of weeks back, I had reached out to Chandra and Hari and asked them, can they give a keynote talk? And both said, perhaps we should do something different. And that's where the idea of the fireside chat came about. Right. So before we get started, I'll briefly introduce. Of course, they both need no introduction, but for the benefit of those who are from other domains, right? So Professor Chandra Bhatt is the Joe King Endowed Chair Professor of Engineering at the University of Texas at Austin, and he's the director of the National US DOT Center on Understanding the Future of Travel Behavior and Demand. So he's been a pioneer in the formulation and use of econometric methods to analyze human choice behavior for transportation and urban policy. So he's won numerous awards, including the 2017 Cutsy Lifetime Achievement Award, 2015 American Society of Civil Engineers Frank M. Masters Award, the 2013 German Humboldt Award. Uh, he is one of the top 10 transportation thought leaders in academia and was awarded by the Foundation. And in 2022, he received the Theodore Matson Memorial Award from the Institute of Transportation Engineers. So he's also the editor-in-chief of Transportation Research Part B, arguably the best journal for any transportation researcher working in methodological topics. So it's indeed a pleasure to have you today with us, Chandra. And we also have with us today Hari Balakrishnan. So he's a Fujitsu Professor of Computer Science and Artificial Intelligence at MIT. His research interests span from network computer systems with interest in sensing, perception of sensor-equipped mobile devices connected to the cloud or edge devices running in data centers. He's made numerous contributions, including in the area of course, mobility and congestion control, right? Resilient networks, wireless networks, mobile sensing, so on. He is a computer scientist with a PhD from UC Berkeley and a BTech from IIT Madras. Chandra also is a BTech from IIT Madras, and they're both distinguished alumnus of our institution. He also has received numerous awards, the latest being the Marconi Prize, perhaps the highest honor to electrical engineers, right, in the field. He recently, or not recently, I would say, sometime back, he co-founded Cambridge Mobile Telematics, right? And they are the leading provider of telematics and analytics in the US. So really a pleasure to have you with us today, Hari. Let me get started with, an interesting thought that occurred to me, right? Chandra and Hari both had professors as fathers, and they were both at IIT Madras. And then it just gave me a sense of, what you can say, an assurance that my son will come out well in his life. Right. So, Chandra, you've been very passionate about transportation modeling for so long, right? Could you just tell us what got you into this field, right? What motivated you to get into transportation modeling, transportation research?
Well, thank you, Geeta, for organizing this. And for those of you who don't know, and of course, Geeta doesn't need any introduction either. Geeta, he is able to go along so many different dimensions at the same time. It's just really an unbelievable gift to be able to do that. Certainly been one of the brainchilds, if not the brainchild of the Mint Collaborative, as it seems. It's interesting you asked that question, Geeta. I initially went into transportation by a process of elimination. It was not like I was really interested in transportation, but none of the other areas of civil engineering seemed to draw me in. And I will say when I first joined Northwestern University, I was not even quite too sure about the sub area until I took a course with my advisor then, Frank Koppelman. And the whole notion that transportation is about quality of life, that it is about how we can serve human beings. And at the end of the day, it's about accessibility. And Ramki was talking about equity. I think it all really came together in my head. So while I was perhaps planning more to go into a lot of computer science related processing and sensing, I switched directions at that point in time and decided human behavior is probably the most fundamental issue. And so I do a whole lot of analysis into consumer choice, which I have a joint appointment with economics also. So it's really, what's going on in the brains of individuals? How do they make choices? What makes them feel good? What doesn't make them feel good? And it comes back to quality of life. So it's such a vast interdisciplinary field, draw from psychology and behavioral science a whole lot, to the point where people sometimes ask me, are you in engineering? And I say, yeah, I am in engineering, but then it is so connected today with basic sciences. So that's the way my pathway unfolded.
Thanks, Chandra. So really interesting, and the interdisciplinary part is something that drew me to the field as well. Of course, Hari, on the other hand, is from computer science and AI. So Hari, your journey into mobility must have been very different, right? And of course, the genesis, I believe, was the Cartel project. Maybe if you could briefly talk about that and your journey in mobility.
Yeah. First of all, thank you for organizing this event. It's such a great initiative to see at our alma mater, and it's a real pleasure to be here with you all today. So, after I graduated from IIT, I went to study at Berkeley and got into the area of mobile computing in 1994, which at the time, laptops were really big. There were no wireless consumer wireless technologies out there. And the work I did led to and helped influence things like what happened with Wi-Fi and cellular and so on with respect to communication protocols. And when I graduated and came to MIT around 98, there was some sense in the broader community that we're seeing a convergence of computing, communication, and sensing, computing, wireless communication, sensing into smaller and smaller form factors. Now, this is about 25 years ago. It's completely obvious now. We call it IoT and all of the, phones, mobile phones, and so on. But anything could have happened, but there was just sort of this idea in the air that this would happen. So actually in 99, I started my first project in this area. It wasn't related to transportation, but it was called Cricket. It was an indoor GPS system because I realized that GPS didn't work inside buildings, and built a system for 5 years to measure, to sense indoors, including, to get accurate location within a few centimeters. Around 2004, we moved out from the city into a suburban area, and I had to start driving to work. And I found that increasingly it was taking more and more time to drive, and the roads were getting worse and worse. And I just sort of had this idea, and there was a colleague of mine, Sam Madden, who had just joined the faculty, and I said, why don't we take all our sensors and just put them in the cars? And now it's obvious, but in 2004, it wasn't, nobody was doing this type of thing. And so there was no consumer technologies available for that. So we built our own devices. We worked with things like Nokia phones and did this project. So for me, the entry into it was based on a very, I understood the technological side, but it was based on this, very personal curiosity. Why are the roads so bad, and where are the roads bad? By 2007, my postdocs and students and we had built the system on the Cartel project called the Pothole Patrol, where every week we would partner with Boston taxi companies with accelerometers and other sensors and do what today is called machine learning, which at the time we didn't really think was machine learning, but it was really processing sensor data with AI algorithms. And every week we would publish a list of the worst 50 roads in Boston. And that got picked up by the press, and a lot of people got excited by that in Boston Globe and the Wall Street Journal. So it was very driven by personal curiosity more so than any grand plan. But I've been with it now for 20 years.
And of course, you're now a leading luminary in mobility, right? We all know that. So, I wanted to get started, maybe I'll first start with Chandra again. Chandra, the Mint Collaborative has as its tagline, mobility dreams for 1 billion, right? So, of course, we are more than 1 billion, but in India, but we're not only building for India, we're building for the world, but fairly large scale. So given such an outlook for the collaborative, what do you think, are the priorities, all right, that the collaborative can look at in the next 3-5 years?
Yeah, I don't, I'm not an expert in sensing or communication or processing. That is certainly Hari's domain. I do feel that technology has so much to offer today. It's just an incredible time. It's a exciting time. It's a challenging time. The discussions that we have routinely include, are we going to have even traffic signals today? Or is it going to be simply a queuing system with what might seem like chaos, but vehicles are, just going through intersections very efficiently through a queued process, all done in near real time or real time, and with high safety. In the large scheme of things, we might have time to elaborate more on this. I think safety is the one place where technology and AI-related approaches can help quite a bit. In all of this, the one thing I hope we don't lose sight of is that, as efficient as we can make mobility systems and transportation systems, there is nothing like, at the end of the day, reducing the number of vehicles on our roadways. And that comes back to some of the basic points of sharing. I'm actually awed by India. Each time I come back to India, what might seem like chaos, I'm like, wow, what an efficient way, the way things are built. You have mixed land use. You have shops, you have residences, you have everything so compact geographically speaking. Walking and bicycling is so easy and so accessible to many. And I can understand why this is happening, but it's almost like India is in some ways moving toward the Western world in having exclusive enclaves, the segregation of society by income groups, etc., through these exclusive enclaves, but then it increases distances in general. And ironically, we over here are moving more toward the Indian system as it exists today, or at least existed before, which is how can we have more of this community feel, more of the mixed land use type facilities. So this idea of compact land use, compact geographic footprint for our travel, I think we should not lose sight of that. Now, not to say that technology and connectivity doesn't have any, it can do a whole lot of good in many ways, but we can also focus quite a bit on pedestrian movement, bicycle movement, and I know Hari was just talking about doing something in that area. So let's not focus just on vehicles, let's focus on other modalities also.
Right. I think that kind of gives us some vision that the collaborative as a whole can aim for, right, as research priorities. So Chandra, you mentioned about technology and what it can do, right? And no better person than Hari to talk about how technology, AI, how it is redefining multiple disciplines, but in particular mobility, right? And Hari, what according to you is going to happen perhaps in the next 3 to 5 years, grand challenges that can be solved with AI in mobility?
Yeah. So I think we'll start from the end goals that we might want. So there might be three. I think Chandra alluded to them. The first would be, in no particular order, I think heading toward reducing the number of crashes, maybe even zero crashes, which I think is unlikely, but I think certainly reducing the number of crashes. And I think it's really important that, as Chandra said, this has nothing to do with this is not only to do with people inside of these armed vehicles, but 50% of the people affected by seriously injured are outside the vehicle, pedestrians and bicyclists and so on worldwide. And so that's important. So getting that. The second is related to congestion and how we handle that. And I think we've made some progress, but I do feel like there are many parts of the world where things appear to have become worse. Some of it due to technology. For example, these systems that now we all use at scale with our phones, I think they've reached the point where they themselves start to, it used to be when 5% of people were using it, you don't have big societal impacts, but now you have larger scale impacts when, everybody uses a Waze or a Google Maps or something like that. And, I think that those organizations can now start to make a bigger difference and interact more with policy makers where, the idea that a Waze would put people on these little quiet residential streets is probably not what we want as a society. We made these roads for different purposes. And the third is emissions and sustainability. I think those are three goals. Eliminate crashes, eliminate congestion, eliminate emissions, right? High level goals. So if you look at where technology is going, I think in the 3 to 5 year time frame, almost always things don't progress as rapidly as you would think, but over a 10 to 15 year time frame, they do. So if you play out what will happen in the next 3 to 5 years, I think that one of the big advances that will happen in the research side and start to see commercial deployment is edge AI. AI models increasingly deployed on IoT devices on the edge, that is in the vehicles, perhaps even in the infrastructure. However, I think that over the last 2 decades, it has been quite disappointing to see how poor roadside infrastructure is from the standpoint of technology. And I think the sustainability in terms of, not environmentally, but in terms of cost sustainability, economic sustainability of that is really difficult. It's easy to put a camera somewhere or a computer somewhere. It's really hard to maintain that in the most rugged and inaccessible of situations. So I suspect that we're going to move more toward less in infrastructure and probably more toward just in the endpoints. And maybe the elimination of traffic lights happens not because they all become highly coordinated and so on, but simply that, combination of vehicles becoming more intelligent. But I don't think it'll happen very quickly. But I think research there would be very, very helpful. So I think edge AI is one that I think is very valuable. The second is there are now many organizations that have managed to acquire data on mobility at fairly large scale, at a very granular level. From millions and millions of users, not just what's happening every 5 minutes, but really what's happening at a fraction of a second. And I think I'm excited by that, not only because we can improve these 3 problems with respect to infrastructure, but also with human behavior. Incentivizing people to do the right thing, because now you have deeper understanding. You don't just have demand patterns, but you actually understand how they drive. But you also understand how vehicles behave, and you have good models of how the best human drivers will behave, because I don't think we're going to be in an all autonomy world for the next 15, 20 years minimum. And so it's going to be a very hybrid one. And I think the opportunity to use technology and AI to fundamentally improve vehicles is exciting, because it is the case that vehicles have become laden with technology, especially since 2017, and they've arguably become safer, but the data on crashes shows that it's rising. This to me is a real paradox of technology. Vehicles have become smarter, quote, smarter and smarter and smarter. The data absolutely doesn't bear out that improvement. And there's very interesting studies about how humans interact with technology. So I think these are the opportunities for research and probably entrepreneurship. But I suspect nothing significant will change in 3 years. But I think a lot of the research happening in the next 3 to 5 years can make an impact in the 5 years beyond that.
Fascinating. And that kind of nicely segues into the next question I wanted to ask Chandran, right? So you talked about human behavior, right? And technology, and perhaps no one better than Chandra to talk about human behavior when it comes to transportation. So Chandra, if I were to ask you, you have to make your plan for, say, next 5 years, 10 years timeline, what research you want to do, right? You, of course, seen transportation plan change in the last 25 years, right? The way it was in 1990s is clearly not how it is now, thanks, of course, in large part to what you and others have achieved in this domain. But going forward, what do you see as the direction that transportation planning researchers need to take, right? Especially in this changing scenario.
Yeah, I can, I would say it would be primarily in the broad spectrum, and Hari already alluded to this, in the area of human-computer interactions. Now, it might seem like, it's a buzzword, but there are so many different elements to it. And let me just talk to two elements of this. One is the almost real-time interactions between humans and vehicles and computers, whatever you want to call it. I suddenly get a message from a computing system. Do I believe in it? Should I believe in it? How do we provide information to drivers? A simple example, we know that if I'm driving on a highway, and then there's a message flashing that says exit off, congestion ahead. That does not seem to impact my choice too much, because I like the status quo. I like to do what I have been doing all my time. On the other hand, it seems like a simple twist to it that says exit off, a crash at a particular site, and being a little bit more specific about that, that immediately seems to trigger a reaction in our brains, and there is more of a chance that I will divert off. So what is it that makes people take advice without feeling like they have been patronized? I think that's one element of the human-computer interaction. The other element, and this might also go back to what Hari was talking about, as technology seems to be flourishing, it also seems to have some deleterious effects on things like crashes, etc., etc. And I'll come back again. I don't know that we study human behavior in terms of what we call unintended consequences. I think these unintended consequences are so critical to projecting what might happen with technology. It's one simple example. What we have found in some recent studies is we have all of this lane assist, we have automatic cruise control, automatic braking. Ostensibly, all of these things help safety. And I'm not going to question that they do help safety, but there's also an offsetting effect. What's the offsetting effect over here? What we found is that, at least in the United States, motorists on average, there's a lot of heterogeneity, drive about 3,000 miles more on an annual basis if they have all of these safety technologies in their vehicles. Why? Suddenly, safety is improved and exposure might not be that much of a concern. And so that's an offset. And so they start driving more on those same vehicles. Now, we all know that as we drive more, it's more exposure and more risk of crashes. So how much of the additional miles is offsetting some of the technological benefits of all of these gadgets? So this is such a vast area, and I think we really need to focus much more on how humans behave. And by the way, this is not just to recent technology. When airbags were introduced, when seatbelts were introduced, and by the way, I'm not saying that these are not useful. We should wear seatbelts, and technology must have airbags in the cars. But you know what happened? As soon as these were introduced, what we found in our testing beds about the technological effectiveness of airbags did not quite port to the field. Why? As soon as I know I have cushions all around me, I start driving aggressively. And so some of the benefits become offset. So I think these are the kinds of issues we need to keep track of. So to answer your question, I think this whole area of human-computer interaction, how we receive messages, and how we react based on new technologies, I think this is a fascinating field.
Yeah, if I may just add on, I completely agree with these points. I think there's a couple of aspects of technology that have been that are relevant here. So first of all, people become complacent or they ignore it because there's a lot of false alarms that show up and so on. So we have a recent study that we did where we had data on people who drive a Tesla who also drive another car. So there's some number of people who have multiple cars, and often people with Teslas have another car because of range issues. So what we found was very interesting. When we compared their performance driving in a Tesla with and their performance in the other car, we found that they drove a lot safer in the Tesla. So we thought, well, this is exciting. Maybe Teslas are safer. But the study actually found that they become worse than the average driver of the other car, because they get used to some of the things about the Tesla, which has lots of advanced features, and then they get into another car which doesn't have things. And so I think that is an effect that when you have people who are going between cars, and I mean, in the Indian context, there are professional drivers who come in and they're driving many different cars. And if the capabilities of those cars are different, and that is in fact widening, we might have an issue. The second, which has been pretty interesting, is that as technology has come more and more into vehicles, a lot of that technology is around infotainment as well. And people use their phones quite significantly in vehicles. I call them weapons of mass distraction. And the reaction of vehicle makers is completely reasonable. They put more and more of that infotainment into the car's infotainment system. And honestly, that is even harder. So now you have to figure out, at least on my phone, I more or less know where things are. But now every car is different and it's hidden away. So I think we end up with the same issue of the human-machine interface that becomes quite difficult no matter what that machine is doing. So I think these are very significant challenges that it's hard to tackle, because anything with human studies is very difficult, but I think it's valuable for researchers to tackle.
Yeah, thanks, Hari. And I had in fact another question for you, but again, that kind of flows in well to what Chandra was saying, and I think what you also followed up with. We do have a Center for Responsible AI at IIT Madras, right? So when we talk about technology, it also comes with responsibility, right? So in this context of mobility, you think are some of the issues of concern or conflicts that you envision in the use of AI for mobility, at the same time not sacrificing on responsibility?
Yeah, I think there's many aspects to responsibility. I think the more immediate practical one has to do with understanding from a user's perspective what data is being gathered about them and what is being done with that data, because modern AI is all about harnessing the power of data. So I think that consumers whose data it is have to have utmost confidence that the data is not going to be used in a way that would hurt them. I think that is probably the fundamental degree of responsibility that we need to tackle up front. And it's not about privacy. People talk privacy. It's really more about trust. People are willing to do things, send their data or do things as long as they trust the entity and trust what is being done with the data. As far as responsible, software more broadly, not just responsible AI. I mean, I think of it as responsible software, responsible computing, with AI being a significant component. I think that it's really important to try a lot of empirical studies and understand what happens, because I'm struck often by this issue of, well, you have an autonomous car driving and you can either go and hurt a child, or you can go and kill 3 old people. What will you do? Well, those are all great hypothetical questions. I've driven, and we've all driven for many years. I've never once had to make that decision. I mean, I've never had to choose between killing a child and killing 3 people. So I think some of the framing of those questions have to be more realistic. And I think that I believe very much in empirical approaches to this problem, understanding what are the key decisions to be made, what are the 4 points where there's a conflict, and then try to understand and tackle them with data and real evidence. I think some of these things, some of it comes today in systems like maps or Google Maps or Maps or Waze, where there's a responsibility to figure out societally where you want the traffic to flow. What were the planners, what did they have in mind? How is that evolving versus where you want the traffic to flow? So I think that those types of problems would be fascinating to work on.
Yeah, I mean,
So,
I-
Geeta,
Go ahead.
not to usurp your role here as a moderator, can I ask a couple of questions to Hari?
Sure, it's a fireside chat, right? That's informal. Go ahead.
So Hari, a couple of questions that I have. There is this sense, at least in my field, that cameras, they are able to capture, fair skin tones much better than darker skin tones. And we are concerned a little bit that it might actually perpetuate some biases that we see right now, wherein infrastructure in majority Black neighborhoods are simply nowhere close to what they are in majority non-Black neighborhoods. There are so many elements to it, and we can talk about it later on. But is this really the case? Is this true that technology still favors a certain skin tone color as opposed to other skin tone colors? And I know that even in India, you have heterogeneity even in that. And so would that imply that, the pedestrian fatalities we see among Black population groups is so much higher relative to white population groups? And again, we can unpack that, but certainly it is true. Does technology handle this, or am I mistaken? And the second very quick question is, we talk about responsible, fair, equitable, AI and everything. Sometimes, and I'm not an expert, and I talk a lot with people in this area, I feel like they seem like buzzwords. Are there real metrics to talk about these kinds of things?
Yeah, so on the first one, I do, I mean, it's a loaded question, so I should be careful. I think that there's no fundamental reason why algorithms can't adapt to any of those issues with respect to skin tone and so on. I think there are two things. One is the training data that needs to make sure that it's broad enough. And the second, I do wonder, I've seen these types of things and I've experienced it myself. When I got the very first Kinect camera thing, it was not really working very well for people in my family versus some of the other kids who would come in. But I actually wonder to what degree, and in the road case, whether it's related to lighting more so than the color of somebody's skin. That is, there's adequate lighting. And the other thing is that we now, even in the dark, we have infrared on almost all of these cameras. So I don't think there's a fundamental issue there, but I'm not denying that there are practical issues related to training data, related to lighting conditions and so on, which might be difficult to tackle in the short term, but have to be. Insofar as responsibility is concerned and metrics, there are things that people study and write about which are related to disparate impact, which is they sort of say, all right, if you remove out certain factors, then there's a baseline, and then I add some factor in, and is the impact of that disparate or disproportionate? So there are people trying to define these types of metrics, but I don't think that these can be purely technical metrics. They have to come backward from the eventual outcome that we want. So for example, we all are experts in transportation. What does it mean to have an equitable or fair allocation of traffic to roads? Even in traditional computer networks, you have the same question, like what is the meaning of a fair allocation? And you and I we have many definitions of it. So I think we have to decide from a standpoint of policy or judgment what it is we might want and make arguments or to come up with those. But yeah, to a large degree, I think it is a buzzword laden area, and it's become quite hot and frothy. But I think ultimately there's some core to it, which has to do with making sure intuitively we feel like certain things are fair and certain things are unfair. And more importantly, consumers, as you are an expert in the consumers, feel that way. So it's really important to understand why they feel that way, whether they really understand it. And often this relates to transparency. If things are very opaque, they don't understand it, they just say it's unfair. So I think maybe that's the way to tackle it as we define the metrics.
Thank you, Hari.
Thanks, Chandra, making my job easier. So, no, since you started asking a couple of questions. I'm told there are questions among the online participants. I'm sure there are a few questions here as well. So maybe we'll do a round of questions and then I'll come back with a couple of more of my own later. Rama, can you ask the person online who has a question to unmute and ask the question?
Yes, absolutely. So, hello, Chandra, Hari. Good to see you both again. We have a couple of questions in the chat. So what we are going to try is see if they can unmute and speak the questions out themselves, because I think it's better coming directly from whoever wants to ask the question than have me paraphrase. I'd request Vivek Vupala, who has a question in the chat, if you would be able to unmute and ask your question.
Hello, I'm audible.
Yes, go ahead.
Yeah, good evening, sir. I just had a question. When we talk about autonomous driving, you see, in the Western world, Tesla is giving you that autonomous feature. But when it comes to the Indian context, do we see that as the practicality? Because there is a mix of human drivers as well as autonomous vehicles. So will that be a practical use case? Because the human driving patterns are very unpredictable in this part of the world.
Yeah, I can take a stab at that. I'm really curious to see what Chandra thinks. So, first of all, I think this is a challenge everywhere, but I think India is very challenging. My feeling on this is that we need a leap in AI before it becomes real, not just in India, but in other places. And the leap has to do with understanding human intent. Because a lot of mobility, especially in India, is, you see there's a bicyclist, there's some pedestrian, and you make an eye contact, and often you don't want to make an eye contact. You go like Newton's first law, like linear motion, without looking at anybody, assuming that others will react. So I do think that there's a lot of understanding intent that AI does not yet know. So I do believe it'll be quite challenging. And I don't think that's just in India is particularly challenging, but it's challenging everywhere. I suspect very much that the way autonomy will get into society is initially, I mean, we have all the stuff going now, but in the end, on major roads at certain times of day, they'll have dedicated lanes. And then they'll sort of start rolling it out like that. That's my feeling. As for whether that happens in India, maybe it'll happen with long distance overnight trucking as a start. And then maybe it builds out from there.
Yeah, I agree with Hari. There's an issue even in the United States. It's not like, if we put human-driven and computer-driven vehicles, it's going to be hunky-dory here. It's just going to be, and that's really the key, right? The next, we believe it'll take at least 30 or 40 more years, and Hari might have a different view on this, before we can find en masse in the United States autonomous vehicles going all over. And the reasoning for that is simply that there is a certain turnover time. We buy vehicles, we keep them for an average of about 8 to 11 years. And even just by that token, if we have autonomous vehicles in the market, it's going to take some time for the turnover. So it's a challenging issue and exciting issue at the same time. How do we manage both? Now, some countries are working through what is referred to as autonomous vehicle lanes. So classic, separate out the vehicles, right? That seems to be an easy way out in the immediate future. You then start having considerations of equity just like how they are labeled Lexus lanes today, when you have high occupancy toll lanes, etc., you have all of those issues that start to come into play. The one thing I would say is that is, at least in my opinion, a fundamental behavior, you could call it cultural or whatever. And my daughter actually wrote a very nice essay about this, that when she visited India, she was, at an intersection. I think she was about 16 or 15. First time she was venturing out alone by herself in India. And she saw one of her peers on the other side of the street, and those sea of vehicles, separating them. It was a roadway separating them. And she was just unwilling to step on the roadway. and she wrote something about how the other person on the other side was so nonchalantly stepping on the roadway, absolutely confident that the motorists will stop for him, will give him way, and then, he went past her buzzing this wonderful Hindi tune that she knew. And so she was saying, wow, this is just quite unbelievable that this person knows that everyone else will stop for him. Now, there are issues you can take with this, but the idea of, this is everyone's roadway. This is everyone who belongs over here. And I think that's one of the reasons why I think in some European countries like Netherlands, where you also don't have, you walk, you don't walk. It's my right of way, it is your right of way. The number of pedestrian fatalities are way lesser in some of these European countries. So I think these concepts of let's all make do, let's all work together in some ways, and we can think about it. I think it might be beneficial for India in this human computing driven context, more so than perhaps it is in some of the Western world.
And I have to really a very quick anecdote. I have known a case where someone having to cross a very crowded road in Tinagar flagged an auto to cross the road.
Wow. I mean, we did have a director speak about how if you could have autonomy in Ranganathan Street in Tinagar, then you solve the problems for autonomy in the world, right? So I think we have the use cases here.
Yeah, like I said, I do think understanding human intent is a very challenging problem for AI. It's challenging for humans. So I think that until that really happens, I doubt we'll make impact in these high dense situations with a lot of hybrid mobility.
Rama, there is one more question online before I ask people here in audience.
Yes, there's one more question, and this one comes from Mint CEO Ramki. So Ramki, please go ahead.
Yeah, hi. This is an absolutely amazing fireside to listen to, and especially the comments around the human behavior, right? So I come from an automotive background, and we wrestled with the fact that we're putting technology to make vehicles more safer. Clearly, and I think I was typing this particular question as you were speaking in terms of the other factors, and then Chandra, chimed in about the human factors. So, for example, the technology paradox you were talking about, Hari, relative to, okay, putting more technology, and at the same time, you find that the number of crashes are increasing. I guess the human factors or human behavior clearly is the factor that is not accounted for in terms of this particular change, right? And I wanted to know if there were any specific studies on the speeds increasing. Like when I came back from China after 10 years, and I was absolutely aghast looking at how it was in the US. You were just seeing everybody, if the speed limit was 70, they were all at 80. Okay, so it like there's an inflation in speeds, right? So is that something that also as a society, has changed the behaviors? And maybe just as you kind of rightfully said, as the intensity or the scale of technology increases, certain things come and affect the whole society. So I just wanted to probe that. And I have another question later, but I think it'll be good to hear your response to that.
Go ahead, Hari.
Oh, no, go ahead if you have a response. Yeah. So I think there's a question of whether speeds increasing so on. But I would just say there's a lot of unintended consequences of any technological improvement particularly when that technology has to do with people. I think Chandra alluded to this thing, people become complacent. They think they're safer. I think that's fairly fundamental. During COVID, we saw a dramatic rise in the speed of driving, even though mobility overall dropped. And now what we're seeing, for example, is that mobility has returned at volume, but it is smeared through the day. So there's no longer as much of a rush hour, but there's sort of this smearing out through the day that has happened. So there's a lot of unintended consequences of almost anything that we do. But the very hardest thing to empirically study is the interaction between humans and vehicles and collect that data and collect those behaviors. So I think it's a good opportunity for researchers because we make a lot of technological changes to vehicles, and yet we find these things, have surprising consequences. And this has happened for 40 years.
Right.
So, I guess it's related to your question, Ranki. It seems to me, and again, I'm not an expert. Hari is the expert in this. It seems to me that we need to design technology for even the extreme cases, even if they are not that probable. Now, a simple example that comes to mind is, as human beings, let's first give ourselves our due. Our human brain is just incredible in terms of processing, in terms of making decisions under conditions. Do I flout rules? Yeah, I do flout rules while driving. When, for example, I see a vehicle that's coming on the other side that I think is leading to a possible crash, I take evasive action, even if I'm crossing the middle line and I'm crossing the yellow line to go to the other side. So, I mean, as human beings, we make some judgments sometimes. And yes, people say that human judgment is the reason for most of the crashes, which may be true, yes. But, we don't sometimes see how many crashes have been averted because of human judgment. The times I'm just shaking my head where I think, oh, this is going to go for a crash. And then one driver takes an appropriate evasive action, and that's it. Okay. So there's so much of cooperation that happens that we don't see. And I wonder, in technology, can it also learn that, hey, this is not totally rule based? You can flout rules if you have to. The bottom line is safety. And Hari's, from his reaction, absolutely, Chandra, we can do it.
Yeah, I think that is the way these technologies are evolving. I mean, they have sort of rules as guidelines, but ultimately they seek to learn from data. They seek to learn from what works in empirical practice.
So just a comment on that from my experience developing technologies in the automotive field, right? So what happens is you test out a particular technology in isolation, look at all the modes and all the the space in which it's supposed to operate, right? However, the effect in terms of deployment in scale and the interaction in or kind of movement across society, I don't think it's ever been part of the technology development cycle in terms of really understanding how the technology would play out in real life as it's scaled up. I think that is probably something we need to kind of alert the automotive OEMs to kind of think about as a best practice in terms of actually incorporating. The second question that I had was more related to the one of the objectives for Mint is to curate data and actually kind of have certain things put together in the tech stack, which is kind of a continuation of the India stack, so that people can develop solutions on top of it, right? So I'm just asking what technology, what challenges do you see as you curate masses of data, right? Big data, specifically for mobility. And what is there any advice that you have for Mint in terms of what are the big problems to look at, what you have found so far?
I think one of the big challenges is understanding causality. You can collect a lot of data, you can draw inferences, there are correlations that happen, but then the types of questions have to do with, okay, if I make change X, what is the impact Y? Can I use the data to judge that? So I think causal simulations are pretty important. They're very hard to do because you have thousands of confounding factors. I'd say that's probably a significant challenge to tackle, where I think computer scientists can help people who are domain experts in that type of problem.
I think, this issue of causation and correlation, I think is also key. To give another example, in this study I just talked about, where as you put more technology, people seem to be driving more. If you look at the data as such, what you will note is that people who purchase technology into their vehicles, they are a self-selected group. And they tend to be the ones who tend to be very safety conscious to begin with. And that's why they load themselves with all of these technologies. So if you look at the data as it is, you don't get this finding that as people buy these, have these technologies, they are driving more. Because when you look at the people who purchase these technologies, per se, they are very safety conscious and they don't drive more. But after you account for that self-selection, then we see that in the population as a whole, if people have technologies, then they tend to drive more. So I think these kinds of understandings of trying to tease out, and by the way, I'm going to have a talk over here at UMass about causality and correlation in a more broader way today. It's a very slippery issue, causality. And there's so much heterogeneity even in the causal direction. And from what I understand, as much as we have made progress in neuroscience, it's extremely difficult to see what's going on in the heads of people, and even the head of individuals, brains of individuals. Cause and effect keeps changing directions over a certain period of time. So it's difficult to make out what is causing and what is the effect. So a lot of these, I think, comes back to the excitement that I always have found in understanding and trying to mimic human behavior, which in a very basic way, I think is all about AI.
And I think we're over time now, but in case if there is one question from the audience here, maybe, can we have a mic up here? Ravi has a question.
Hey.
Ravi, if
hey,
you could stand up and the camera can face you as well. Yeah, thanks.
So I'm turning my back towards you guys, but I'm still asking you guys the question, Hari and Chandra. It was a really impressive discussion, truly impressive. A question that always gets to my mind, right? Just to give you a quick intro behind my question, before I started my own organization, Automobile, I was heading the architecture teams at NVIDIA, developing AI. I mean, I was the head of architecture for Orin, which is the latest edge AI device that came out. Before that, it was Parker. Before that, it was Arista and all that. One common trend I keep seeing along the way is the fact that every new generation of edge AI platform that we are building has had about a 10x increase in its TDP, thermal design budget. And the reason I'm asking, the reason I'm correlating this, I hear from Hari that edge AI is the way forward for mobility. And what scares me the most is mass deployment of this and the impact of this increased power budgets at the edge towards sustainability platform. I mean, this is a little off on the other side, but it's going to hit us somewhere. The increased technology, increased adoption of technology is going to impact sustainability. And somewhere they both will come conflict with each other. How do you think we are going to address this if we deploy this edge AI and the appropriate technology at scale in US, across the world, and everywhere else that we can think of? So I'd like to hear your thoughts about it.
Well, I suspect fundamentally that moving heavy atoms or mass is from A to B is generally speaking going to consume a lot more energy than the computing involved. So I think two answers. One is electrification, where the electricity is from clean energy, and the second would be, or any other renewable. And the second is, if the technology does in fact make mobility more efficient, then I think it would be a win. I don't deny the challenge that you're talking about. Without a doubt, it is challenging, but I'm very much a techno optimist.
Thanks, Ravi. Thanks, Hari. I think with that, we'll conclude the fireside chat. I'm sure there are more questions, there are more topics to discuss, but unfortunately, we're out of time. Thank you so much for joining in today, and thank you to the audience online as well as offline here. Over to you, Miriam.
Thank you, sir. Our sincere thanks for your participation in this event. It's now time for the MINS Academic Members Roundtable. I would like to call upon Professor Raghunathan Rangaswamy, Dean Global Engagement. He will be the moderator for our session. I would also like to welcome our panelists, Professor Ashwin Mahalingam, Head, School of Sustainability, Professor Bhargava Rama Chilukuri, Center of Excellence in Urban Transport, Professor Lalita Devi, Morth Chair Professor, Professor M. Manivanan, Head, Consortium for Augmented Reality and Virtual Environment Engineering, Professor Professor N.S. Narayanaswamy, Head, FedEx Center for Sustainable Supply Chain, Professor B. Ravindran, Head, Vadvani School of Data Science, Professor Satyanarayanan Seshadri, Faculty in Charge, Energy Consortium, Professor C.S. Shankar Ram, Professor, Center of Excellence for Zero Emission Trucking, and Mr. Thiru Srinivasan, CEO, Center of Excellence in Advanced Automotive Research. Over to you, sir.
Where is Geeta? So, Geeta has a lot of hope on us, I think, right? First, this is supposed to start at 5:50, 6:10. Last session, he gave us no, oh, more is there. Huh? Okay, then at least that's good news. And I think absolutely no brief on what we should be doing. He only told me you maintain some time. And the most alarming thing in this is, I'm sorry to say this, when she was calling out all the people, I thought all the audience will come into this, and where will the audience be? We have more panelists than audience possibly. But given all of that, I assume this is a panel about showcasing IIT Madras strength, because I don't know whether all of well, I think mobility. Satya, anything to do with mobility? Yes, mobility. Yeah. So it looks like everyone can be fitted into mobility, right? So I'm very happy to moderate the panel. I think my job as moderator is to finish this in half an hour. Right? So I would really like, I think given that now at least I've established there is a coherence in this, there all are mobility. So if you could briefly talk about what you do and how it relates to mobility, we'll go around 5 minutes each. Then we can take some questions. If there are things that you want to ask the other person, we can do that and so on. How does that sound? Too much? Oh, I didn't count the number of people. 4, 8. Oh, that itself is 40 minutes. 2.5 minutes. Okay, start, Ashwin.
Hi, everyone. My name is Ashwin Mahalingam. I am Geeta's colleague in the civil engineering department, but I also head this thing called the School of Sustainability that IIT Madras started almost exactly 6 months ago. We'll be 6 months old on Sunday. The School of Sustainability tries to bring together people doing work on sustainability across campus, across departments, to try to see if we can find intersections where the whole is greater than the sum of its parts. We sort of coalesced on 4 broad areas where faculty come together. One was on sort of scenario modeling with regards to sustainability. A second was on decarbonization. A third was on sustainable human settlements. And a fourth was on behavioral business model and policy change. And I think mobility is one of the few subjects that I think intersects almost all of these. Clearly, there is a decarbonization aspect to mobility. There is a human settlement aspect to mobility as well, particularly if you start looking at non-motorized transport and other ways of looking at mobility. But most importantly, one of the big gaps, as far as research in IIT Madras on sustainability was concerned was that while we were doing a lot of technology related work, we were not doing as much on the behavioral side. And fundamentally, I don't think all the technology in the world can save us if we don't fundamentally change the way we produce and consume things. But people working on mobility for a long time have been addressing these behavioral issues, and not just people now looking at, as Hari was saying, intent and things like that. But even earlier, when you were doing simple things like origin destination studies and trying to figure out why people want to go from A to B. So I think there's a lot to learn from the way people have approached mobility and apply it to other areas of sustainability. And at the same time, I think when you look at sustainable mobility, you've got to look at it beyond just a transportation question. There's transportation, there's energy, there's materials, there's a whole bunch of things that come together. So in that sense, I think this is a really great fit within the philosophy of our School of Sustainability. So I'll stop here. Maybe we can come back later.
Thank you, Ashwin. So I'm going to take a little bit different path. So I'm Bhargava. I'm a colleague of Geeta Krishnan. I work in the area of transportation. So we work in the core transportation area. The transportation division has long been working on transportation related problems. And of course, mobility is a bigger umbrella, right? So I'm going to talk about what we have done so far and what is the path forward and how it kind of can contribute to the mobility thing that we're talking about, right? So the transport division has started working on transport-related problems through the Center of Excellence back in 15 years ago. And actually, we are the first Center of Excellence in India, and one of the 3 centers of excellence that were started. And then we kind of took off from that point. We installed a lot of sensors, instrumented corridors, and collected data and started working on different things from developing technologies, developing sensors, developing solutions, models. So all of these things started back in 2015 and continued for a very long time. Then we got through the process, we kind of extended our research through multiple research projects through different ministries from MIT and Mahua and MORTH. So, and then recently we became one of the IOEs. Through the IOE, we kind of updated our technologies and infrastructure. So now we have vehicle simulators, we have connected vehicles, we have human factor related work, tools and skills that actually enable us to do human factor research. And also in future moving forward, we're actually looking at taking, leveraging all this knowledge, understanding models, algorithms that we have built to actually develop solutions and field implementation. So we are actually in the process of implementing some of the technologies in Chennai. And we are in talk with different ministries to actually translate these technologies for people's benefit. So I'll stop it with that. And yeah, I think it's a very organic thing that will be part of the mobility. Thank you.
So good evening all. I'm a colleague of Geeta in another department called Applied Mechanics and Biomedical Engineering. I'm a professor of biomedical engineering. I come from the biomedical engineering background, looking at the mobility, not mobility. I had a center called virtual reality and haptics. So in the recent time, there is the more and more interest in AR, VR, XR, metaverse. These are the interests is coming up. Our center, if we are successful, it will be anti-mobility. Okay. The reason why I say is anti is going to be if AR is very realistic, we don't have to travel at all. Right. So maybe the people from villages, they don't have to go to New York for working. Sitting at their villages, they can work from at New York, or we can visit the relatives without moving at all. So that is a very far away future. What in our center we are looking at is now how do we make this future reality possible, right? So we are looking at the human experience. The human is the center of the entire activity now, right? In the mobility. maybe the goods or other transport is the center, but here, the human experience is the center. How do we understand the human experience? To understand it, is we are trying to measure it. Once we measure it, there is a science of it. Once we have a science of it, there is an engineering of it, and then there is a technology of it. So this technologies in our center, we are trying to develop better experience in a mobility. For example, how do we give a navigation tool in a mobility using the AR, VR, or better training using the simulators like we have done it. Human factors is the one of the main thing we are looking at it. And how do we measure the once we have this training, then also rehabilitation. If there is a road injury, how do we rehabilitate? The offset of all these things, we are also working with ISRO, where the ISRO astronauts, we are trying to send the ISRO is trying to send the human to the space. While they are sending it, we are using these mobility tools, whatever we are creating in AR, VR, to help the astronauts, getting them trained in the several first aid procedures and design the interior of the human capsule using this anthropometry data. Human factors will be used over here. I hope we'll be able to help Geeta in many ways in the coming days. Thank you.
Moderator privilege. So now I just don't want to end this meeting as for 8 disparate things, right? So I'm going to give you all some homework. So at the end of it, I would like to each of you to tell me one demonstrator project where all the 8 of you can contribute. One each. So that means you have to listen to the other person. Yeah? Okay.
Hi, good evening, everyone. My name is Narayana Swami. I'm from the Computer Science and Engineering Department. I happen to be one of the 2 heads of the FedEx Center for Smart and Sustainable Supply Chains. We are dealing with many problems to do with logistics and sustainable supply chains. The first of them is find a shorter name for the center and a nice logo, right? But that's a problem that FedEx wants branding and everything. That's such a joke. So the center's foci are 2 of them. One is to make the logistics space healthy for the workers and also sustainable in the sense that vehicles should be running to capacity. I mean, if you're running a truck, it should run to 50% full capacity. And the approaches that we are taking, we have one group which is working at algorithms, machine learning methods based on data that are available. And another group basically is measuring worker health using different devices to understand what the state of a logistics worker is, whether the worker is going to be in a warehouse or the worker is a driver, and so on and so forth. So therefore, those are the 2 foci. And our hope is actually to be able to design methods and processes and reach out to the logistics community here in India, right? So though we are funded by FedEx, there is this big expectation from FedEx that we will solve questions which are more global in nature, but many of us have some common thought process that we will actually contribute to the logistics community in and around us in many ways. So couple of examples that I would like to give, which actually motivated me as a computer scientist working in algorithms to actually try and see how those algorithms can be applied profitably or socially beneficial way to the logistics sector. So I was coming back after a trek from Himachal, and after a very arduous trek, as you come down just before Kullu, the bus, I was coming by an air-conditioned Volvo bus, and the bus stopped at a bend, and there were people who just were selling apples, apricots, and stuff like that at unbelievably low prices, at something like 5 rupees a kilo. And there were people who were running a hard bargain and got 5 rupees, 5 kilos for 5 rupees, right? And if they just managed to get that just 150, maybe 200 kilometers down to Chandigarh, they'd have got a better price, right? And the thought that occurred to me was that the bus actually had so much space for all those cartons which were sold at throwaway prices, right? So to me, the problem that occurred to me as a computer scientist was there's free space available in this bus. How does one actually advertise it? And how does one actually make it more profitably useful to these people? So this was one thought that occurred to me. The other one that occurred to me was that I tried to do I spoke to a lot of railways people. And one of the things that was not um, not clear was there predictive systems that could help station masters, for example, um, um, accelerate certain trains or change the speed of certain trains so that organizational goals like coming on time. So drivers, so I know some drivers in the family, today you get penalized if your train actually comes a little earlier, and you also get penalized if you come a little later, both, right? And often the running speed is not completely in the control of the driver because the larger information as to what causes the delay is not available to him or her, but available possibly to station masters. So I did this project with students where we crawled a website called the Rate Branch System, got a lot of track information, and we simulated the railway network as an academic project. Very recently, we met a company called Instavans. Vinay Goyal is a founder who's an IITM alumnus. They're actually doing the same thing to ensure that freight actually moves more effectively on the rail network. Apparently, freight moves at 9 kilometers per hour. So to do 2000 kilometers, a freight can take, right, as much as like 15 days, right, is what the time it takes. So apparently companies uh, push station masters and so on and so forth to ensure that freight can move faster just to save few tens of lakhs of money, right? Not few, many tens of lakhs of money. So there are many practical problems. So I entered the world more as an idealist trying to apply computer science, but kind of figured out that there are people trying to make money. Instavans is one company that I learned very recently that they're trying to make money by optimizing freight networks, understanding how railway networks works. So I hope what I've said is very clear. Yeah, questions. Thank you.
Hi, good evening. I'm Satyanarayan Seshadri. I head the Energy Consortium. Mobility and energy, as you think about, they were twinned at birth. I mean, the real modern mobility started with steam, and that has been the source of problem also. I mean, what we set out the consortium is a vision to say that we will enable a low carbon transition, and bulk of the problem is in mobility. The others are easy to address. Mobility is hard. But I also see that as an opportunity because each of the directions that we are taking, be it electrified mobility, intelligent systems, and so on, all of that are moving power plants for me. And they are mostly idle in most locations. So we are looking at ways by which we will really monetize it, really use it, and make it in such a way that there is a shared economy that gets created. So one of the projects that we are starting to look at is vehicle to grids or grid to vehicles. So how do you utilize the unused vehicle that's probably sitting in parking garages in the offices to stabilize the grid, for example, when you have more renewables? So these are very interlinked problem. These are something that we are trying to address, and then so on. It goes on to, there is this whole topic of green mobility, and there is no green without understanding what is green, and then it goes on into the, again, source of power. So power becomes an essential element of mobility. The last question that we want to lead with the behavioral aspects that we really talked about is, in the energy world, we say the best form of energy saved is the energy that's not consumed. So do we have something similar? The best form of mobility is that which is not taken up. So that goes back to Manivanan's point, where can we really have most of the work done where we are sitting and really only use mobility for experiential fun? Thank you very much. Looking forward to working with Geeta and seeing what more we can do together.
Thank you. Hi, I am Lalitha from Transportation Engineering Division, and I am here as I am the occupant of MORTH chair professor. So I think I don't have to now connect to mobility or anything, right? I can save a lot of time. Transportation, more. Okay. Anyway, since I am here, I will just explain a little bit about the MORTH activities here. So this is Ministry of Road Transport and Highways. They instituted a chair professor position here. So the activities mostly are R&D help for ministry. That is what the broad outline is. They have given some areas in which they would like to collaborate or help, take help from our side. One of that is intelligent transportation systems, with a lot of specific examples given, but all of those are areas in which we work a lot. Then there is safety, there is pavement engineering also as one of the areas. So there is a lot of activities that's happening. Currently, there are 3 projects running. One is on, or 2 are in the area of safety, collision warning system. Then signals is one area in which we are looking. We heard Professor Chandra saying eventually we will have reservation-based signals, right? We are not going there. We are more looking at fixed time signals, adaptive signals, actuated signals for Indian conditions. We are still working with a code which is written in 1985. We haven't changed it. So we are trying to rewrite that code or have a new code written. So those are the activities that's happening currently. Moving forward, we are looking at mainly 2 big projects that we want to accomplish. One is have a smart track where we will have sensors in the pavement, in the vehicles, in the infrastructure. And we want to study this all components of mobility together, pavement, traffic, and the control, everything together. So that's one project where we need a test bed. We have to kind of equip with a lot of sensors and then study. The second one we are looking at is something where we want to have a Mint is one inspiration where we started that. We want to have a mobility stack where GPS-based solutions for the entire country. So, the digital twin which we are right now looking at, that's one area we are looking at. So both are very ambitious big project and definitely Mint and we have to collaborate. Thank you.
Good evening. I'm Shankar Ram from the Department of Engineering Design. So just like the esteemed colleagues on this dais, like I come from a department which has a diverse background. So engineering design is not a typical department in many institutions, but we are here at IIT Madras where we have people from several disciplines working together. And of course, automotive engineering is one core focus of the department, and I'm from that particular stream. And here I'm representing the Center of Excellence for Zero Emission Trucking. That was set up close to about 1 year ago. So this May 1st, we will turn 1. So the broad objective of the center is to become a nodal agency, to enable the adoption and acceptance of zero emission trucks in India. While working with government agencies, OEMs, and other stakeholders in the environment, including fleet operators and drivers, who are also very important stakeholders, along with mechanics and after-sales providers. So if you look at Indian conditions, we have around 2 to 3% of road vehicles being freight trucks, right? But they contribute to around 40-45% of CO2 emissions. That's the statistics, and I think I learned something thanks to what Narayana Swami told, 9 kilometers per hour. Road freight is certainly faster than that. So obviously road freight is still preferred in our country. And more importantly, we are also talking about energy security, right? Because these trucks consume a lot of diesel, right? So from both aspects, the adoption of zero emission trucking is being very seriously investigated. So it's of course, it's an evolving topic. So the center works on multiple verticals, we work on technology, the technical aspects. We are also working with experts to enable policy and regulations. We are also working on skilling, which is going to be one of the important verticals. That is, as we transition from internal combustion engine based trucks to electric trucks, right? How do we enable a just transition, so that everyone in the ecosystem benefits? Of course, OEMs and big tier one companies can take care of themselves, but what about other stakeholders, right, in the entire ecosystem, right? Can we help them? And we are also looking at pilots, right? along with, working on, even driver training and also like enabling drivers for in this journey of adoption, right? And in fact, the homework problem given to us, right? I immediately could think of one thing, based on what people could look at, like because it's truck drivers' job is very difficult, like I'm sure all of us agree, and I think I'll come to it when given the chance.
Thank you very much. Really appreciate the opportunity. Thiru Srinivasan, I'm representing Center for Advanced Automotive Research. The work that is done in academia tends to be heavily focused. I mean, it's not a universal truth, but for the majority on TRL 1 to 4. And that is where they are very comfortable. That's where they do a very, very good job. And then most of the time, industry is, even the best industry who do a lot of R&D, they will take it from maybe 6, but most often 8, TRL 8, at a maturity level of that, and then they'll take it. There's a huge gap. And in Germany and some other places, we have seen institutions that are able to fill the gap. And the objective of CAR is to fill the gap in India and then bring most of that research that industries work with to India. We're expecting about a $400 billion R&D automotive research. We'd like to bring a significant portion of that to India in the coming years. And that's what CAR has been established. And it has been established as an independent society rather than be part of IIT, even though it's incubated by IIT, to give us the flexibility to do it whichever way it takes and achieve that. That's the number one thing. It's translational research, and it is something that industry would be willing to work much closer. It takes a lot of conversion of industry to work with R&D. Mostly people misunderstand R&D in Indian industry for the most part. So we're trying to convert that. We work with academia to make sure that we are deriving a lot of support from the work that they are doing up to TRL 4, sometimes TRL 5. There are a few faculty who do go beyond that. So we derive sustenance from them. But ultimately, CAR hopes to have its own facilities and things focused on that intermediate TRL level research, including prototyping, testing, validation at that level. So it's quite ambitious. And the way we go about doing this is we work with industry, identify the problems they have, and then we identify the resources that are available that are willing to work on that. So if we find about 200 problems that is in the industry in this area, we find about 20 people who are in the competence to work on it. So that limits what we do. And then we provide proposals, and it's usually a collaborative. It's a consortium type work for the most part. And then we execute the program with the industries investing in it. In this, we are working on dynamics as an area. There's a significant amount of work that's being done, particularly on the two-wheeler and three-wheeler space. Suspension, brakes, steering type activity. Then the second area is on motors for electric vehicles. And one of the things that we're looking for is on e-axles, but also a lightweight motor so that we can get more of the motors into the wheel and then so give more space for cargo and passenger space so that the vehicle is more useful. And then we are also working on the battery, because where we are at the stage where we are, we're focusing on characterization. Can we really characterize the battery properly so that we know at what level of health it is? Today, it is still a black box for the most part, and how it is degrading, and develop test methods and things for that. And we're also working on software, driven vehicles. That's a very, very ambitious, because I haven't found enough resources to work on that within our reach, but there's a lot of demand. The supply is the problem. So we're starting to put something together on that. And then we're also working on the charging network and the power electronics. It's a huge amount of effort that needs to be done where we can charge easily, fast, ubiquitous. And so there's a tremendous amount of ideas, particularly for long range vehicles and things like that. We tried to get more funds working with the union government, the state governments, test centers. They have recognized that such facilities, such research facilities don't exist, and they are starting to support. So I'll talk about, since I've heard everybody, one problem that we can all work together is how do we develop vehicles? We focus more on vehicles. How do we develop vehicles that are a lot more utilitarian? And how do we make sure that the vehicles to drive is easier, not necessarily autonomous driving, but easier to drive? You don't need a lot of training to get the ability to drive a vehicle. The vehicle is easy to drive. Make it easier, assisted driving. And how do we make sure that the data, if there is a safety vehicle or something that's coming about a kilometer away, you start forming some lanes or something like that. So information that can flow dynamically. And so you're able to get to a point of wherever you want to go faster and safer and provide priorities.
Okay, so I was looking at my watch. We started at 6:10, so I thought we have 40 minutes, so I'll stop at 6:50. So we have 15 more minutes before we go around for maybe 5 to 7 minutes. If the audience has any questions, I think we can take it.
Hello, good evening. It's very interesting to know about the challenges. I am Sivakumar from ZF R&D. So interesting to know about advanced automotive things. So personally, I have been working on automated manual transmissions and e-mobility in ZF. So the challenge which I face is affordable technology. So the truck drivers, they ask what is the payback, any technology. So that's the area we are not able to penetrate, particularly in India. So at the zero emission trucking, are you taking care of the cost aspects, or how is it managed?
Of course, you need to get take this response as coming from a core academic. Right? So typically we don't look at finances and money, but thanks to my interaction over the past several years with various industry experts, to me you're spot on, right? So the success of this is going to be decided by money, right? Whether it makes money sense to transition, because although one may say, hey, there is a lower operational cost, like for electric trucks, the capital costs are significant, right? And I can't state publicly, I can talk to one about some things which I've learned, what to say, over the course of the last 2 years, some of which, I can't say in an open forum, but where the drivers, particularly truck drivers, may lose out on some income sources, right? If we automate too much, right? And if you go to electric trucks, right? But I can share whatever I learned with you. And one interesting tidbit also I found, learned, which I'm sure industry experts here can supplement, is that like typically the trucking segment is very unique. Of course, in India, the segment is dominated by small players, right? Those who have fleets of 5 trucks or lower, right? And I learned that most of them make money only when they sell the vehicle, which was, I was, completely taken by surprise. Then I learned why, right? So these are all unique things at play, right? So I agree that, we need to take care of finances. That's why the center is working on enabling schemes, right? And also regulations, which focuses on all these stakeholders, right? The fleet operators, the drivers, the financiers, and also the mechanics. I believe strongly that these set of people who are not typically talked about, right? typically when we talk about these mobility, we talk about ministries, policymakers, OEMs, tier one companies, and so on. Right? But this set of people is equally important, right? So I agree, money will drive the success of adoption, right? So, but then OEMs, major truck OEMs have declared publicly, right, a deadline by which they would transition to ZETs in India, right? So, which is good news.
So I'm not an expert in the field, but maybe you already know what I'm going to say. What I'm saying that apparently many trucking companies are also designing for a business model where the trucks aren't owned by the agency that purchases it, but they kind of get into a hiring kind of an arrangement where they kind of own it for the business purposes, but finally it's also the difficulty of them making money only when they sell it is not there. Actually, initially I started off trying to make the comment saying zero emission trucking is possibly actually another name for rail freight. But
Well said. I think one thing that I've seen that has been done in some of the other countries that have successfully, and other industries where they successfully dealt with the cost problem, has been systems thinking. If you look at electric vehicle, battery is a very large component. And everybody focuses on how to make the battery cheaper, sometimes put in lower quality cells and things like that. But if you look at the whatever that is used to move per kilometer, a lot of that is coming from the powertrain and other areas also. And if you can make a better powertrain, then you can actually pay more for the powertrain and less on the battery because you can put a smaller battery. So we're starting to see a lot of value in systems level thinking and looking at bringing the overall value and cost. Of course, one longer term is total cost of ownership. That's a hurdle, but systems level thinking then bring down the initial cost of the vehicle also.
Looks like you asked a very interesting question. Everyone wants to answer your question. But we'll take one more question where only one will answer. You have? Yeah,
Maybe I'll try to ask that question.
Yeah.
So how do you think this transport as a service or mobility as a service evolve in India?
Who wants to take this? Lalita. Math professor.
No, actually, Professor Karthik is the correct person to answer that question. He is in the audience. But I know a lot of, so the question is mobility as a service, how it will evolve over time, right? As far as I understand, I don't work in that area. India has already a lot of things like paratransit and all those, which is happening. And then Uber, Ola kind of thing, where the facilities are already there. It's only the adoption, the people accepting that and then using it is what I understand. As I said, I don't work in this area, so maybe one more person should answer this.
Satya, you want to take a shot?
I think mobility as a service was the first service model that started. Only based on that, now every other as a service model, heating, cooling, energy, everything came because you went from personalized transportation to public transportation. That is mobility as a service. That's one of the early adopters of as a service model. And the question that he was answering about leasing trucks, nobody owning trucks and all, I think that's already there.
Okay. So we have last 6 minutes to close this. So Shankar.
Okay, the homework.
Yes.
Right? So, yeah. So, okay. So what I found very interesting, like I said, like, like I strongly believe, we need to take care of truck drivers, right? So as we, behavioral aspects, as Ashwin mentioned, something which is very important. We need to also look at the conditions under which they are working, this kind of stress they face on the roads. And of course, one good thing our government has done is introduce legislation where the trucks are going to be air conditioned, right? The cabin is going to be air conditioned zone to enable better comfort, right? So these are very positive steps. But in the context of zero emission trucking, right? So can we all work together, right? So to enable better driver education, right? We are tools, for building simulators, like which will train drivers to drive electric trucks, for example, and behavioral aspects, right? How should one react on the road, right, when they face certain situations, particularly under long, stressful work hours? That's something we could look at.
Good. Instead of asking more questions, then we do this. We'll take that as a problem. We have 3 minutes. Each one will say how they will contribute.
Yeah. First of all, this is not homework. We have not yet gone home. This is only classwork. Okay. So you can tell how Raghu teaches his classes. All the students are probably going up in arms. So I think I really like the overall training idea. I think there are different dimensions to training. One is, of course, you can talk about safety, you can talk about efficiency, sustainability. So I think one aspect of sustainability that we would really like to contribute to, one aspect of training that we'd really like to contribute to is really see to what extent we can measure emissions, etc., and try to make not only figure out ways to make the whole sector greener, but also impart that as education so people can make the right choices, whether it's in terms of buying trucks or driver behavior and so on. Second, I think the behavioral aspect is something that I think is critical. I don't think it's something that we can bring to the table, but I think we need to partner with people outside the IIT ecosystem who understand this better and bring that as a part of the training model. Also, in terms of, there's a lot of training models where a lot of the training doesn't get done because you don't understand the receptiveness of the person you're trying to train. So I think there is behavioral questions at multiple levels, right? Including how do we actually get these people to understand what we do. So, yeah.
Yeah, so with respect to the training, I think training in India is, the driving in India is the most complex thing, right? Once you drive in India, you can drive anywhere. That's what it's. So I think given that the amount of heterogeneity that you see on the roads in terms of vehicle classes, in terms of geometry, in terms of driving skills of people around you, and then technologies that are out there, people driving connected vehicles versus regular human-driven vehicles with limited information, more information, and then the different environment in terms of the context that you are driving in, the traffic conditions, environmental conditions, all this. I think it's going to be a lot more challenging to actually drive or make a driver ready for all these different scenarios. I think the first aspect will be to actually first understand what happens in each of these scenarios and what are the pros and cons and limitations of each of these participants in the system, and then try to kind of help them through maybe a simulator-based environment or something where you build appropriate models that reflect the reality much more realistic way, and then go about training them to, and then kind of give them strategies how to approach or respond. So I think it's a pretty complicated problem, but I think something that's doable.
So skill training is a straightforward solution with virtual reality and AR and all those things. But let me give another suggestion. May not be practical, but it might, it might get somebody to think about in the right direction. So, like a teleoperation, we help doctors do the telesurgery now with now virtual reality and the haptics. Similarly, if a truck driver sitting at home, if he can drive the truck, I don't know whether it will make his life better or behavior better. I don't know. Yeah, but definitely without technology, it may be possible, but the safety of the road you have to take care of. Thank you.
So the problem that I will pose is basically to measure the decisions made by the driver, different actions that the person has done continually, have a digital twin, mimic that behavior and the decisions. And the outcome of this output of the system would be to kind of decide whether the driver is healthy enough to continue driving or should take a break or something like that. That basically involves digital twins, multiple realities, measurements, and so on.
So in this problem, I would like to add an additional element, which is interaction with the community that happens. The truck driver, be it the large fleet operators or the last mile. There is almost a continuous chain of operations. And if I were to wear the hat of how do you get them to a greener solution, it also involving the community in saying how they can engage with powering those trucks. So I would like to look at this as a problem of community engagement and helping these truckers, either first mile or last mile, getting their power from the community itself where they are serving and taking back from. So that way we would potentially also solve for this current problem of chicken or egg, where the charging infrastructure comes first or the electric systems comes first. And how do you make the truckers themselves part of the solution rather than being resistant to the solution that our friend said? They don't want to do it because there is something else that comes that prevents them from converting from our existing solutions to electric solutions. So can you incentivize them to actually switch is what I would like to consider.
When we teach basic traffic engineering, we always say the most difficult part is the drivers. Don't touch, because we can't model them. That's what is the question that's going on. So it's the toughest part, how to train them or how to get the correct behavior from the drivers. Yeah. So one solution I had was mostly what Professor Narayanasamy also told, have some kind of proper training using digital twin, lot of sensors that can collect data and use those data to kind of have that, the machine learning term training process to show what goes wrong, how the behavior is, or what are the things that could have been improved. So it's more like a training process. But ultimately, you need to, as we again teach, educate them, enforce things so that the drivers will eventually be behaving properly. But it's a tough problem. It is the toughest problem we have. Great. Thank you.
I think the same thing that we talked about on the cost. Ultimately, you have, I think you also alluded to this, incentivize, understand incentives that is driving the driver, and through the incentives, make sure that you're training them, not through deterrence or anything. Telling people to wear a helmet, if they can see what happens when they wear a helmet and they're saved, if some, if simulations, accidents can be shown to show the seatbelt and helmet saving, then people will be more incentivized because now it's a real incentive for them. Rather than saying 500 rupees fine, may not be a real incentive.
Thank you very much. And I think with that, we'll close this session. I really thank all of you for being a sport and answering. You could have just said, get lost. I could have done nothing. But there are 2 points that I've been in many panels recently, I think, because you become Dean Global Engagement, I think. And most of these panels, I kind of ask myself, why is the audience there? Right? What is it that they are learning from this? So I've been thinking anytime I get a chance to be on a panel, I'll try and do different things. So this is the first time I tried something like this, but thank you so much for participating in this. I hope it was useful and informative session for all of you. The other point I also want to make is the reason at IIT Madras, we are trying to bring people together. Typically we are all in our silos and maybe some of these will start making us think about contributing to others' problems. So just something to think about. And that's part of the reason why I did this also. But anyway, thank you so much for listening to us patiently, and on to the next session, Geeta.
Thank you, professors. Now it's time to felicitate our panel members. I would like Professor Raghu to felicitate the other panel members. Professor Ashwin Mahalingam, Professor Bhargava Ramachilukuri, Professor Lalita Devi. Professor M. Manivannan. Professor N. S. Narayanaswamy. Professor Satyanarayanan Seshatri. Professor Shankar Ram. And Mr. Thiru Srinivasan. I request Professor Geeta Krishnan to felicitate Professor Raghu. Thank you, professors. Now it's time for a short tea break. Tea is arranged at the main dining and we will resume after 15 minutes. Our final session of the inaugural Mobility Summit is the moderated panel on technical issues and mobility solutions. For this, I would like to invite the moderator, Dr. Ajay Gumala, entrepreneur, onto the stage. I would also like to welcome our panelists who are in person today. Dr. Gaurav Agarwal, AI ML expert, and Mr. Ravi Bulusu, founder on Mobile. We have 3 panelists who will join us virtually. It is my pleasure to welcome Professor P. Rajalakshmi from IIT Hyderabad, Dr. Ramachandran Balakrishna, Principal Transportation Scientist, Caliper Corporation, and Mr. Rajiv Chenan, CEO, You, Me, and Us. Over to you, sir.
Hi, everyone. Welcome. Thanks to the esteemed panelists for this discussion on digital technologies for mobility solutions. So if you heard all the sessions since yesterday and today, all of them focused on what is the problem space, right? Where are there opportunities for us to, for this center to actually innovate, and like what are the types of problems we should be solving. So this session is going to focus on what are the solution space that we want, right? What are the pieces of the solution space that we can go after in this collaborative. So so I think the specifically we would like to focus on the Bharat multimodal mobility stack, which Professor Geeta has presented. So what could be the components of that stack? So how I want to run this session, initially we'll have everyone like 3 to 4 minutes to give their opening comments. And then we'll have some targeted questions, what we think are the right parts of the solution. And then we'll have open question Q&A with both online as well as the audience here. So first I would like to invite Dr. Agarwal. He is an AI and deep learning expert and an entrepreneur who works on the intersection of highly scalable, efficient learning models and application to diverse domains such as healthcare and agriculture. So,
yeah, so my sort of exposure to mobility came, I'm a computer science graduate. I'm an LM from IIT Madras, graduated 20 years ago. So my exposure to mobility came when I started heading machine learning at Ola Cabs. So it was like my mother-in-law thought actually like when you work for Ola, it seems like you are a driver. So I had to convince to her that I'm actually driving lakhs of cars every day, not one car. So just to, my marriage was in trouble literally. We thought we married, our girl to a PhD and all that. Suddenly you are working for Ola. Thankfully, she got convinced eventually. But I'm not going to talk about that. I mean, ride-hailing is a well-studied problem. But in addition to that, I am also a very active volunteer with iSpirit, which is one of the sort of institutions that is very active in India stack. So for me, when we were talking about DPI and DPG, that's like sort of, that's what I eat, sleep, drink as a volunteer with iSpirit. And most likely, most of you are aware of iSpirit. Like UPI is one of the biggest sort of thing that came out of iSpirit. So, Geeta talked about all these, like there is data, like we are 1.4+ billion of us, we travel, we do everything, right? So there's data, but where is it? It is in silos. It's not just mobility. Think of healthcare, think of agriculture, everything. It is in silos. Some of it is private data. Some of it is actually not even private. So to handle this problem, like we have data, but we don't have models. All the models actually that we use, they actually come from outside. So it's a very strange situation that we have data, but why don't we have models then? And we have to use models trained on Western data. Just doesn't make sense. And the reason is what Peter mentioned yesterday, this data is in silos. How do you share data? I mean, there are privacy concerns, or sometimes there are no concerns, but you don't want to get into legal trouble, right? I mean, you share data and you don't know how it will be used. So in fact, to address this exact problem, what we have been working on at Iceberg for the past 3-4 years is a privacy preserving techno-legal framework for data collaboration. See, I'm not talking about data sharing. I call it data collaboration very carefully because, like, suppose I have some data, and let's take the example of healthcare because it's very private data. The same logic applies even in mobility. So suppose I am in hospital, I have data. Now, entrepreneur comes and says, I want to build a model for a specific disease. You share your data, and probably we go around all hospitals. The challenge is, like, if something happens, if the entrepreneur leaks that data and misuses it or gives it to insurance companies so that their insurance rates jack up, that's not what patients signed up for, right? You need is, like, you can't share data, and anonymization, while Geeta mentioned it, but it is an art form. You know, it is anonymous till someone has not really tried to de-anonymize it. Most things, unless carefully done, it's only soft anonymization in some way. So what we came up with is, like, so basically data collaboration on the other hand, it's like, the model and the data, instead of transferring it somewhere, we make the meet in something called as confidential clean room, which is built upon the concept of confidential computing. And even the model that gets trained in there, it's like a safe room where where two people come and shake hands. Here they are not people, but it's the data and the model code. You come and shake hands, you train your model, and even the model that goes out, actually, it is validated whether it has memorized anything using the principles of differential privacy. So thankfully, the field of differential privacy has evolved a lot in the past few years. So it is a very potent tool, technique to actually validate whether the model is memorizing the data or not. And once that model goes out, the data has never reached the sort of the entrepreneur in my example, but the model has been trained. And this data can again come from 10 different sources with different kind of data that you need. And this, it is not a concept that we talk about. In fact, the source code is live on GitHub, and we are actually piloting this with various use cases. So in fact, I would love to work with Geeta as a dear friend to actually, let's try this out. We want to, like, stress test it and everything. So as it is part of iSpirit, it is all open source, all collaborative. There is no money involved anywhere. It is, yes, but having said that, the data sharing and other things can have monetary incentives aligned for data donor and maybe coming from data user. But as such, the infrastructure is all in public domain, completely open source, open for any stress testing or any sort of any hackers can try it out, whether it is really privacy preserving and stuff like that. So that's what I'll stop with. We have that capability now as a DPI, which allows for privacy preserving data collaboration, and it should extend seamlessly to different kind of data sources we have, different kind of data units we have in the mobility space. Thank you.
Thank you, Gaurav. This idea of digital prism, privacy prism, is actually quite interesting. Should probably come back to that later. Next, I would like to invite Mr. Ravi Bulusu, the co-founder and CEO of Inaugural, which provides end-to-end technology solutions for supply chain and logistics. He has extensive experience on computing hardware, specifically with the application to automotive technologies. Go ahead, Ravi.
Thank you, Ajay. Thanks once again, everyone, for giving this opportunity. The more I hear about what Mint is set out to do, the collaborative, and my having heard through the earlier panel discussions, the more I feel in place in terms of what we are doing as OnMobile, what I have done in the past, and what I intend to do, at least as OnMobile. I believe we should be able to bring a whole lot of value through OnMobile and personally to this collaborative. And to corroborate that statement, I just give you a little bit background of what I've done in the past and why I feel so much in place in terms of all the discussions that have happened. So incidentally, it so happens that there seem to be a lot of Texas Austin alumni here with Professor Chandra, Dr. Geeta, I believe, and I've graduated from Austin too. Worked at other organizations, Intel, Portal Player, where I've had a fortune of getting thrashed by Steve Jobs at some point in time when I was designing the iPod. But much later, I worked as a director of architecture at NVIDIA. And at NVIDIA, all we were doing was post the consumer electronics smartphone phase where we moved out of it. We were working on autonomous driving, first starting with infotainment. Sometimes one of the things that Hari was talking about earlier, I was feeling guilty that I was pushing that infotainment platform at some point in time in Tesla. But then we moved on to ADAS and worked for many years, I think about 10 years at NVIDIA before I started OnMobile in India, relocated to India and then started OnMobile in 2016. And since then, we've been trying to do something in India for India kind of a model. That's what we've been working on. And over a period of time, OnMobile evolved into, like what Jay mentioned, logistics and supply chain solution provider. And as a part of it, we've been doing technology, logistics, and technology for logistics for major OEMs like Maruti Suzuki, Hero, Daimler, Volvo, many automotive companies, Bajaj recently. I think we've had, and not just the automotive industry, but petroleum industry. HPCL happens to be one of our biggest customers. And the real problems of mobility from that customer's perspective that have been discussed in various panel discussions in terms of driver engagement, the safety are things that have been at the core of the problem statement that we've been trying to solve. Just yesterday in my introduction, I was talking about some of the safety aspects that HPCL has come to us, Maruti has come to us saying these are the problems that we are facing day in and day out in terms of safety. And the most important problem that is very applicable to India is viability of the solution. I could develop like I said yesterday, I could develop a LiDAR that could be installed in the truck that will help provide the most amazing safety solution in terms of 3D depth and all this. But the target consumer I'm talking to could either buy the LiDAR or the truck. He cannot buy both. So he will choose to let go of the LiDAR and say, I will stick with the truck. So the solution had to be a viable solution that could come pretty much. I mean, when I say cost sensitive, it's free. It's got to be for free. And we did something like that. We deployed a solution which was very smart in helping drivers avoid accidents while negotiating curves on the highways, because that happened to be apparently the second most cost of losses for my customer, the HPCL. Right? I mean, at some point in time, they said that's the big cost of loss in revenue for us, and how do we solve it? And what we needed was a very smart solution that was affordable for all the customers. Having said that, the deployment and the practical aspects to it, there are a lot of hindrances that prohibit you from actually going deploying at scale. And I believe this collaborative is the one that would put all these solutions, diverse solutions from different backgrounds, right? I mean, different sources, put them together, leverage the power of intelligence and be able to deploy a solution that is viable for the Indian customer. So that's where I end my introduction right now, but also talk about the relevance of what we are doing to the end customer. Thank you.
Thank you, Ravi. I think we'll come back to your point of like trying to find a cost-effective and driver-focused solutions in a minute. So next, I would like to invite Dr. Ramchandran Balakrishna, who is a principal transportation scientist at Caliper Corporation, USA, where he helps research, prototype, and deploy scalable and detailed simulation models for people's behavior related to mobility. These models are widely used to optimize transportation networks and study future equity, accessibility, and environmental issues. Rama, go ahead.
Thank you. Can everyone hear me fine? Thank you. Thanks for the introduction, and I'm happy to participate in this panel with so many accomplished co-panelists here. I want to take a slightly different view or bring a slightly different perspective on technological challenges and technological solutions, which is a different piece of the mobility puzzle, right? So We all know that the technology space, in terms of both vehicle technology and vehicle related service technologies, is a rapidly evolving one. And in the last decade or so, we've seen the pace of that evolution actually accelerate to the point where we're getting new speeds on a continuous basis about the new latest technologies and so on. But it is also true that all of this rapid evolution is happening on a relatively uncertain landscape, where everybody is facing challenges, and there's no common view of how things need to be done. And this is not necessarily a bad thing. This is how innovation happens. And we've all seen how the driverless vehicle technology is facing various challenges and so on. From the technology side, there is always the question of who will pay for it, right? I mean, there's a question of viability and so on. For technology to become viable, there has to be a market for people who will pay for it and pay for those services and so on. So long-term viability obviously depends on a piece that is not in the hands of the tech developer per se. It is actually in the hands of the end user. So there is a piece to this puzzle, which is how do people and companies or potential users and consumers actually behave? Will they adopt this technology or will they not? And a lot of this actually depends on how they perceive these technologies playing out, in terms of depending on who the stakeholder is, whether it's a safety perspective, long-term operating costs, issues like range anxiety. Hari Balakrishnan in the fireside chat referenced trust, reliability. These are all issues that the end user will have to grapple with. And right now, both sides of this challenge are grappling with uncertainty, right? I mean, nobody knows how this technology is going to deploy out, and hence the potential demand doesn't have a way of assessing whether that is a good fit for them and whether they can make a value proposition out of it. And in the middle of all this, we also have the fact that mobility as an ecosystem cannot stand on its own with just the tech entrepreneurs and the end users. You need to have a lot of investment and standardization that has to be driven for the common good. And a lot of this actually comes from government role in the whole process. But when we talk about common good investment, this could be infrastructure investment to support the rollout of autonomous vehicles, for example, or connected electric vehicles and so on. And also putting policies in place to nudge demand to follow what we want to happen. These investments tend to be long-term, very expensive. So there's a need for planning around this. Yeah, the demand and the supply cannot operate in a vacuum here. There needs to be some long-term vision here and some planning, some what-if scenarios to see whether we can control for some of this uncertainty, but also guide the process towards a place where there is synergy between tech development, tech services rollout, and demand for these services. So I think the main point I'm trying to make here is that there needs to be continuous dialogue between at least three types of stakeholders here. I'm going to call them vehicle technology and service innovators, mobility modelers, and people on governance side. And I'm specifically not using the mint tags of industry, academia, and government for the simple reason that the lines between these groups has blurred a lot, more so now than it was a while ago. So there are academic initiatives that are more in terms of tech development, and then there are also industry participants who are also doing a lot of modeling and data collection and so on. So there is a lot of blurring of the lines here, but these three entities kind of need to come together. There was talk about causality versus correlation and so on. So we need to make sure that all of these are teased out in a synergistic manner. And ultimately, the goal here is to address real concerns from all sides, real concerns from tech development side, real concerns from the potential adopters of the technology, real concerns from government entities in terms of what the long-term future is, and basically trying to control for all any negative externalities that might actually result from this process. So in terms of background, I'm actually, I work for a company where we develop these models, so I thought I'd bring that perspective to the table here. Thank you.
Thank you, Rama. We'll discuss a little more about the common view and how we get data to actually help us to get there. So I think we have only three members today because the other two could not join. So we'll continue. So to the next round, which is mostly like I'll ask a question. I'll start with somebody, but anyone else who wants to make a comment or add on to that, please join. Right. So the first question, because the Bharat multimodal stack is a very data-driven solution, right? To enable us to enable multiple facets of mobility. So regarding that, what are the advances we have seen in data science and AI that really enable that we should be like looking at as part of this multimodal stack? Are there like, I know like Gaurav had started with talking a bit on the privacy side. So maybe we'll start with Gaurav his comments.
I think the good news is like, the advancements we have seen in AI in the past couple of years. I mean, they are more visible now, but obviously this work has been done for the past several decades. I think what we have literally as a capability today is what I would call as the universal function approximator. In a way, like whether it is a unimodal or a multimodal, you have a bunch of data and you have some outcomes. So what you have like what these neural networks or transfer models are, they're very good in approximating what is going on. I mean, they're not perfect. That's why they're approximators. And I think so to me, that enables a lot of things. A lot of questions we are talking about. Like, let's take the case of range anxiety. There is some, some physics and chemistry going on there. It's not magic. It goes down. It's just that our model there is wrong. That's all. I mean, it's not magic. There is a reason. Everything can be explained. There is no maybe a bit of randomness here and there, but it should be possible. It's just that maybe all the factors now have not gone in there, or the model itself has not taken the right contribution from all those factors. That's all. So that is possible today. I just don't know why. I mean, it just requires a little bit of effort. I think range anxiety should not be a problem at all. I mean, whatever is happening in that car or in that battery. So to me, it is very much doable. But that's why I love this idea of this public stack, because suddenly these things are at the fore and not at the mercy of marketing claims by people, and suddenly maybe they show some things for those reasons. So I think that enables a lot of things. We should just remember that. I think the key here is like, how do we, again, as I said, how do we get all this data, reliable data from sources in a way that helps the ecosystem? And that's what I think is the biggest roadblock here. Let's take the example of say beyond mobility, OpenAI, which is obviously a very popular company these days, right? I mean, they started with using public data on the web, but now if you look at them, they are actually forging relationships with Capital One and so many other companies to get more data. And the reason they are doing it is because that's the only moat. Basically, that's the only way they'll keep making their models better. More data, more diverse data. The models are not really changing as such. The technology is not really changing. Yeah, it requires some engineering prowess to deal with so much of data. It's non-trivial. Kind of flops we are talking about is humongous. We have never done that before. But again, the science is not difficult. The engineering is little difficult, but science is not. But in mobility, I think we are still far behind, from reaching that scale. So even engineering is not that difficult. I would really want to see that that we get onto the bandwagon, use them as tools without even over innovating really. Because literally what is available in LLMs can directly be applied to many of these problems here. It's a huge opportunity. For us, given that we are talking about it, it's not just in India, but probably globally, these problems are largely open as a research problem. I think it's a great opportunity to apply them sooner. And there will be hindrances, and counter them, create research outcomes, create PhD thesis around them, and take a, leapfrog ourselves out of this. So make it, this is a problem in India. So let's make it an opportunity so that the research in transportation mobility can really leapfrog us out of this.
So if I may add to that, I think the primary question, if I may reiterate, is what are the technology advancements that are enabling us to make this further advancements in mobility, right? the unique aspect about mobility, right? If the more I think about it, the more I feel like it's an all-encompassing problem. It's not, um, it's not isolated in any which way. I mean, it builds on everything else. It builds on everything else. And if I was thinking about this question while Dr. Gaurav was responding, is what is that single thing that has made this transformative in nature? Like what will take me forward? At some point, I thought, vision-based, anything vision-based AI was a huge transformation that enabled a lot of things to happen, grow at scale. If I step back and thought further about it, yes, vision-based AI was good, but computing at a large scale, right? We talk about the parallel processing techniques, the GPUs or the data factories that we have right now that enabled vision to be processed at that scale made a huge amount of difference. Then, oh yeah, vision compute at scale and making it affordable, accessible made a huge amount of difference is what I felt. Then I thought that, obviously all of this made a lot of sense when 5G brought in a restriction, as in real-time interface abilities. 5G, before 5G, you had 4G, but there were no real-time limitations and real-time guarantees that 5G would otherwise bring into play, which actually is getting further reinforced by 6G going forward. And the way I keep thinking more about it, the more I realize that, all of these had to come into play at the same time for us to envision how we can actually take this application going forward. Everything Dr. Gaurav said is right, but somehow we are probably positioned at the right time. I mean, we are at the right place at the right time where all of these are converging into one place. You have accessible supercompute abilities that I could just use AWS or Google Cloud or whatever. I have amazing OpenCL libraries, vision-based data that is coming in, training libraries, learning database that is put into place, that's come together. And I have everything at my disposal right now. And all of these together are enabling us to get to figure out how to leverage all these technologies in one place, one spot, and be able to build on top of it, which is solving this all-encompassing problem, which is the mobility problem. It's probably the toughest problem to solve. I mean, if I think about the likes of UPI or similar technologies that were deployed so far, they were reasonably isolated to a certain extent, whereas mobility is building on top of all these foundations that are laid so far. So all these have contributed in different levels, but yes, I think we are uniquely positioned to exploit or leverage all of this together and then build that solution going forward.
Thank you, Ravi. Rama, did you have any comments?
Yeah. Let me start by acknowledging the points that both of the other panelists have made. There has been an explosion in the data collection realm due to a confluence of various technological aspects, from compute to storage to cloud to sensing. But if you're looking at this from the perspective of building models, right? I mean, when you collect these data, they give you the richer the data you collect, the more detailed and accurate picture of current reality is what it shows. Now, if you want to do what-if analysis, scenario analysis for, let's say, 40 years into the future, 30 years into the future, what is the future impact, the long-term future impact of transformational technology that is trying to burst on the scene today, then today's data is not sufficient. You have to somehow correlate that and build models that can extend that into the future so that you can predict what the collective outcome of future populations' decisions will be with the technology that becomes available today or tomorrow, right? So from that perspective, when you're trying to build behavioral models, you need a lot more information than what some of these passive sources of data sets can actually give you today. For example, if you count vehicles or the routes that vehicles are taking, there's connected vehicle technology right now, and there are companies that are monetizing that, making extremely large data sets available for people. And these are very detailed in the sense that vehicle positions with latitudes and longitudes are made available at every few minutes, for example. That's a lot of data, but it doesn't tell us too much about who's in that vehicle. It doesn't tell us how many people are in that vehicle, what are their genders, and what works, what employment situations they are in, why are they traveling, where are they going. And how does all this fit together at their household level, right? I mean, if you want to predict how your own household's mobility patterns evolve over a day or a week or so, you have to take everybody into account, not just that one trip that you are on to work and back, right? So you need a lot of demographic information about lifestyle and household structure and so on, which these passive network sensing technologies are at least currently unable to provide. So there have been advances on this front. Some of us who've been in the process of building these behavioral models and planning models and so on, I think the older you are, the older types of technologies you can remember. Back in the day, before my time, these surveys used to be conducted using postcards. You would do a random sample, send out postcards, and hope that people would respond. And the only questions you could ask were what you could fit on that postcard, right? Then technology has evolved. It shifted to phone-based surveys, and now there are companies that run apps where we don't need to rely on the user to tell us what path they took. The GPS in the phone actually tracks their path and tells us. But they do have to put in extra information about who was in the car with them, why were they traveling, where did they go, and what type of activity it was, and so on. But these technology is enabling this kind of more detailed, more accurate, more spatially aware data sets, which are obviously helping us in the field to build these models. But I just want to caution that there are still issues with all of these data sets, especially when you start cleaning them up and trying to build models out of them. You actually realize that no two households are the same. And the same household doesn't do the same thing from day to day. So you have a lot of variability. And when you collect a snapshot of data, it gives you a very limited picture. What many of us have come to realize is that while big data is good, big data is not necessarily big information. There is a lot of repetition in this data. For example, if you go to work Monday to Friday, and if you track my patterns, you'll pretty much see the same thing happening day after day, right? So 5 days of data is not 5 days of information. It does tell you that there is a regularity to the process, but not much more than that, right? So we just need to push on this front and try to get more data that helps us build these behavioral models, which will help us to predict future outcomes more than just what the current data is showing us.
Thank you, Rama. So I guess the takeaway is we have like much more compute available now at a cheaper cost, cheaper sensors, right? We have like AI models which have been trained well, and we have connected systems which provide us the data. So as a combination of all of that, we can build the next generation system. Okay, so with that, I'll move on to the next question. So in yesterday's session, we had like a lot of panelists mentioned UMI, which is Universal Mobility Interface, right? I would like to invite Ravi to share his thoughts on how we would develop such an interface.
If only I had the answer, we would not have to make a huge collaborative out of this, because that's a $1 million problem right now, I think. But yeah, we need to get started at some point in time, someplace. So the way I see it, right, UMI, so-called UMI, I think we are starting to standardize the term as we go. It looks like I was just alluding to earlier, it's built on lots of other foundations that have been placed, put forward already. The way I see this evolving, obviously, it's got to go through a lot of trial and errors before we get there. But I see this as a stack that gets built with the most popular pain point in mind. You pick up a pain point, which is otherwise called a use case, in mind, start building a stack on top of it. For example, if I start polling a bunch of people here, it's likely that people are going to come back and say driver safety is going to be a problem that I want to look at. So how do I actually build a solution that's my first version 0.1 of digital public infrastructure that I want to put together using my UMI stack? How do I put it together? I would like to understand, pull together all of the movement information that I'm able to gather from all the vehicles today, either through mobile phones, apps, the GPS devices, all this together. Understand, extract driving patterns out of it. Look at probably what is the most common source or place of accidents that is extracted as data through a government interface. Today, I believe there's some such data already exists, which is today a little bit outdated, but it still does exist. So we will put that together, extract the data together. So these are individual data stacks that will come in as potentially APIs or other format that has been put forward by Dr. Geeta yesterday in terms of BM3S, right? So all these stacks are going to come together, and that will be the first source in which will be leveraged through learning algorithms and come back with a definitive means by which we can provide safety solutions to the customer. In terms of today, if I were to look at it, right, my customers, the way we do safety solutions is by what is called a voice box. Okay, my digital device, the GPS device is connected to a voice box, which can be very much a mobile phone too, which when you reach a potential source of most common accident happening triggered location, about half a kilometer from there, it starts warning the driver that he is reaching a source of accident prone area, and he needs to be on the watch out. Now, this thing that I am doing as a local solution can get fully generalized, will be deployed at scale to begin with. So there you have a few stacks that I'm using, which is, like I said, high electrical voltage areas, for example, that can be a cause of danger, more source of accidents, my locational information, the speed information. These are the various APIs that I'm starting to build data sources on which I'm building this intelligence. Now that's, let us say, what I'm calling as point one of UMI. The version 0.2 of UMI will start extracting a different level of intelligence from the same locational information. For example, earlier I was looking at locational information by itself, but now I'll start leveraging additional data on top of it, saying how were these vehicles driving? Were these vehicles, let us say, driving with passengers or by being empty? Okay, now I'm taking a different facet of the same data and modeling a different API or different intelligence out of it. I'm extracting different intelligence out of it. So what I'm trying to say is this is a process of evolution where you take an initial set of data, start modeling some level of intelligence out of it, solve the first pain point. Now the next pain point comes into play, and now we say, okay, I have figured out how to develop a solution for this particular problem statement. I now have some of the data that I can reuse in a different model and extract it and augment it with a different set of data that will come in. So over a period of time, these data layers come into play, individual primitive layers that will come into play, learning-based layers that are derivative models that will come into play to actually solve a new set of problem. And over a period of time, it's a castle that we will end up having to build. But starting off from the primitive models that we already have today, that we are going to leverage to begin with, and then starting the second and third layers of inferencing that are going to help build the next layers of stack.
Hello, I agree with Ravi. Just let's dissect this term UMI, right? There is a unified part here and interface part, and mobility is obviously there. Unified means you have to standardize things basically so that everyone, so that's what UPI did. I mean, it is much simpler, as Ravi rightly pointed out, but unification and making banks agree was the challenge. So here again, unified means we have to standardize things. Otherwise, I mean, the interface is there, but everyone talks in different language, so you can't understand each other. The data is used as the models are used because there's no unification. So, and that's where I think having Mint-like initiative is very important. We say we have all the players who care about it, who will be affected by it. So let's just get together and unify things, standardize things. Second is the interface, and again, I fully agree with Ravi that start with simpler use cases. Think again, if I bring an analogy, like, with UPI, I don't know how many of us remember, there was a BHIM app that government came out with. It was never supposed to be a real effort. It was just to show that you can transfer money through phone seamlessly. I mean, they never tried to, sort of compete with private players. Then private players got it. And UPI has gone through like many evolutions, as Ravi said. Like you start somewhere with the most basic, imminent use case, which shows value. And then other use cases like now credit and whatnot, UPI, without when so many things have come up, they will come. And actually, many of them will private players, our startup ecosystem will pick up beyond our imagination. We don't even have to worry too much about it. We have to build the ecosystem and make such innovations which we cannot even imagine today possible. The one thing we have is like fairly educated talent pool. And I think, but what it lacks is like the ecosystem building is what I think, this effort can really lead to. We don't have to largely worry about that second order models. There will be enough people, maybe undergrads sitting in this campus will be building them without even their advisor knowing them. It really, I mean, it will happen because like they are like, even their brains are sharper than any of ours. So let's just give that serendipity a chance. And that's why building this base layer, as Ravi said, I totally love that thought process. Don't try to boil the ocean initially, else we'll be delaying the outcomes which are almost there.
Rama, did you have anything you wanted to add?
Just a minor comment, I think. I mean, these are all great points. I just want to add to that, saying, yes, you do need to lay a platform and start making an impact right away, right? You don't want to start building a stack that will only start showing benefits years from now. So it needs to start showing short-term impacts, and then it can evolve as it goes along. I do want to focus on the fact that UMI has an M in the middle, which is mobility. And in yesterday's discussions, I think Mr. Jaishankar raised a key difference between mobility and transportation. There's a reason why this is a mobility interface and not a transportation interface. And the distinction that was made yesterday was that transportation is a mode focus, whereas mobility is more addressing people's movement needs focus, right? So whether it's people trying to get to appointments or shippers trying to get freight across a global network and so on, it's mobility that counts. You don't want to really deal with how it gets done, but you need to find the most efficient, safe, reliable way to get the job done, right? So I think that that focus should definitely encompass a multimodal approach to the whole thing. So you have an origin and a destination, and we should not be pigeonholed by modes that are currently available or modes that might even be on the radar today. We should be thinking a little more globally about, more futuristically about that, to see what other options might fill gaps in service today that do not even exist in our thinking. I think the other aspect to this is to connect this back to all the discussion we had about data being available. There is a use case here to try to squeeze as much as you can out of the systems because of the availability of the data in real time or near real time. So you have the ability to judge how demand patterns are changing, and tailoring your offerings or reassigning your transportation network resources on the fly. Pretty much to make sure that you can cover the demand with the least disruption and the least extra cost to actually augment your assets. So all of that data coming in at a rapid pace, it of course requires not just the sensing, but also algorithms to make sense of it in near real time to try to give some feedback so that networks can be optimized quickly and on the go. So I think that would be my perspective.
Thank you, Rama. So I guess what I heard from the panel was we definitely need to standardize, right, the interface and make it available as a public good, right? So it's much more broadly accepted. Then we try to start with some real problems and build that stack up. And one of the elements you mentioned was about multimodal element to that stack. And then once we build the stack, a lot more innovation will happen, which we cannot even imagine today. The fact that you have these diverse data sets, you can draw a lot more connecting dots and create like newer solutions, which we cannot even think of just as yet. So that was pretty good feedback from the group. So I want to move on to a last question, and I want to think about in this industry, right? We have rapid growth, right? And more thinking about like what type of talent and capabilities are needed, right? And what can this collaborative do to help in filling gaps in skills that might be limiting the growth in this industry? Rama, shall we start with you?
All right, sure. So from a modeling perspective, given my background in building models with behavioral data, I would say one of the key needs of the hour is for skills that can kind of bridge the gap that exists currently. Many of us feel that there is a gap between some of the data science related aspects like machine learning, artificial intelligence, and how they are applied currently to the available data sets. There is a perception, at least in a small fraction, or maybe a big fraction, I'm not sure how big that fraction is, of the modeling profession, that there is a slow movement away from trying to look at actual behavior and causes of people's behaviors and so on, towards applying machine learning and artificial intelligence to the hordes of data that's coming in today and trying to find patterns in them. I'm not saying that's not a key part of it, but there needs to be a balance with that and towards trying to figure out how much of this is just pattern matching and how much of this is actually behavior that's driving that data set. And when we can bridge that gap, marry the skill sets of behavioral modelers with artificial intelligence and machine learning experts, I think that's where the best progress can be made in terms of taking all of this data that's rapidly and continuously coming in and trying to recalibrate, retune our behavioral models on the fly, for example, and push them out so that you have some level of confidence in what those models are actually predicting. If you hyper calibrate a model with today's data, it's not necessarily true that it will even predict tomorrow's behavior correctly, right? So we need to have a lot more confidence in terms of how much behavior is driving that data set versus just noise. I'm not saying it's one or the other, it's a combination of both, obviously. There is behavioral pattern underpinning all of this, but there is also a lot of noise on top of it. So I think skills to bridge this gap, rather than just be in one side or the other, are going to be critical in moving mobility forward.
Shall I? So I think I'll try to read this question that you have as, what does it take for us to make this Mint Collaborative a successful initiative, right? Technology for sure. Okay. So I think a few years ago, I would have focused more on the technology aspects of what will take it, what will make it successful. And my esteemed panelist, he's already highlighted some of the technical parts. Over a period of time, I have donned the hat of a CEO for the last 7 or 8 years. And the more I see through it, the more I believe that it is the operational aspects that are going to make this, that are going to be the bigger challenges in making this a big success. I believe that the place where I'm sitting right now, I will never question the ability of technology solving any kind of problem that we have. IIT would be no question about it. It will solve any kind of problem that you throw at it. And at some point in time, I think I'm digressing a little bit, but bear with me on this. But at some point in time, I had this one-on-one with my CEO, ex-CEO, Jensen Huang of NVIDIA. And the thing he told me was, you throw any kind of technology problem at an IIT grad, he's going to solve it. He's going to he will figure it out. You don't worry about how he's going to figure it out. The biggest challenge where that needs to be solved as a group is the operational aspect, enabling and throwing a non-binary problem at it, right? A behavioral aspect to it. Being able to put the government aspect of the government pillar being able to put the industry pillar and the academy pillar, all these three together to cohesively work and solve is going to be the biggest aspect. Once uh, as this collaborative actually puts this framework in place where all these three guys can come together and then work towards a specific problem, agree upon and work towards that problem, I think that's like 90% of the problem solved. Once we all agree and then we have a framework, we say, this is the challenge we want to go solve, and all the hurdles, execution hurdles are taken care of. Solving the technology problem should be the 10% problem is how I feel. That's how I see this as a problem. I mean, there are lots of technology aspects we can work on, but I'm pretty sure there are very, very capable people that can solve this. My biggest challenge, I believe we'll go through, is this aspect of it that we should collectively work towards. And it's easier said than done, I know, but I think that's what we want to get out and get started on working.
Yeah, I agree with Ravi largely. And see, I think it is all about incentive alignment. And that's what operational hazards sometimes are. I mean, in this meetup, obviously we'll agree and we'll make grand plans, but our incentives at every individual level and industry, academia, government level, are they aligned? Again, I'll go back to, like, let's take examples from the past. Again, I'll come back to UPI because there's similarity, simpler use case, but massively adapted use case, right? So in the early days, I mean, none of the banks wanted to adopt UPI. And the reason was, like, they say, like, when people come to banks, we cross-sell things, we make money. When they do NEFT or whatever, we make money. Now we are saying, let go of that money. Makes sense. But what they didn't realize is, when you use UPI, the money doesn't go anywhere. It's like a pointer. Instead of pointing to Geeta, now it points to me. So money never leaves the bank. That's even better for banks. Now they have more money to lend. So they didn't look at it. They looked at the few rupees that they make in transaction, but they didn't realize you actually lend more money. The money is almost always in the bank. There are only so few banks, so it actually stays there. So that is what you have to make them realize. So I think that in identification of incentives and aligning them, that's what creates magic. If any player here thinks like, it is taking away my job or my profits or whatever, right? None of this will work. Same way with talent part also. Obviously, it is heavily multidisciplinary. I mean, either you can create custom courses so that, people have these skills, or just, again, for students, again, create incentives so that they go out there and do it. I really believe that's how humans behave. Why do startups work? Because there is a huge equity, a huge upside out there. I mean, you may have a mission also. I mean, I'm not discounting it, but it motivates you to work harder. Why do sometimes, like, why do, IITs work very well, but the lot of other government offices don't work? There's no incentive. They will get promoted the way they do, right? I mean, it doesn't help. So we should just make sure, and it is even with the like-minded people with the good sort of common mission. I think the incentive alignment starting from upskilling students or skilling them in a cross domain way to making sure all the players stay true to the mission. I think let's just identify those incentives and make sure we make it a win-win for everyone. Professors should write papers, students should get jobs and degrees, go for PhDs, and private players should make money. I mean, that's the only way we can win. There's no other way.
Thank you, Gaurav. So what I heard, like, to solve technical problems, you definitely need to have like a lot more cross-functional elements. Don't just go chase after AI. So you actually need traditional modeling or / traditional domain knowledge, as well as definitely the cross-functional AI elements as well. So you can leverage the best of both, right? And then on top of that, make sure you're even more diverse than just technical side. Build on policy or like regulatory, like how do you interface with them? How do you solve some of the operational issues? People should, or students should be exposed to that, and that the collaborative can enable some of that. And the last element was make sure the incentives align with the different elements that are part of the collaborative, right? Different people have different objectives. We need to find the right model, make sure they all align between academia, industry, as well as students. So that's great feedback. So I think that was the main set of questions I had. So now if you have any questions, either online or, okay, Ravi, go ahead.
Hi, my name is Ravi Chandran. I'm not a technology guy, but I have gray hair or no hair. And so my question is, last 2 days, I've heard all this humans are the center of the whole thing. Behavioral adoption is going to be the key. Everything is. In today's session is digital technologies for mobility solutions, and we have said mobility dream for $1 billion, and I'm involved with that. A simple thought crosses my mind. Is there a way? You look at India, it's roads. We're talking about chaos, talking about everything there, and we're saying, can we solve some of the key problems to reduce that chaos? We also know that, I don't know, 80, 90% of the guys on that road have a cell phone. Out of that 90%, maybe 60% will have a non-smart cell phone. Because that's the ratio today, 60, 40 or 65. And we want to solve problems for them. Now, instead of going on saying new things, new technologies, 5G, 6G, if this is my real situation, are there digital technologies that you can devise which will collect data and use those cell phones which are available on the road, and everybody is on GPS today. So you know where they are. Use data to say how I can actually try and solve these problems in an experimental way in one area. What are those digital technologies? Instead of creating new technologies, instead of spending more money, instead of getting more and more expensive, use the existing situation. What are those digital technologies? What are those directions that we can do? I'd like to pose that question to this panel.
I think you're very right, sir. So, I mean, we did that with Arogya Setu in a way, right? Remember, Arogya Setu was not perfect, but it was part of the health sector, and we sort of did it. Like, suddenly we wanted to move, but we needed to know if in our area or in some area, whether we got in touch with someone or close contact with someone who had COVID, so that we can isolate ourselves or we don't go to that area, whatever. It's the same thing, actually. So I agree with you. We should not we should not try to have grandiose plans which don't do anything and just burn money and finally, lethargy will, come in. I agree with you fully. I think these phones are there. We can have at least experimentally, maybe in area around IIT Madras or other college campuses where it is easier maybe to have voluntary students to have an app installed there so that you are collecting all this data without any privacy issues and create sort of use cases which reduce this chaos. I fully agree with you. And it's not very hard to do it even with the feature phones, actually. I mean, they don't have GPS, so you will not need GPS, I guess. But many other sensors are probably not needed.
If I may, I think just to add to what Dr. Gaurav was saying, right? What you are suggesting is something that we do in the domain of transportation, for example. So you're
in the domain of road chaos.
Exactly. So what happens is, just to give you an idea, about a real life application that happens today. Okay, there is, like you said, 40% smartphones, 60% non-smartphones. Today we have to deal with drivers who do not have the smartphones. Even if they do, they don't let you know that they have smartphones. So they only talk about feature phones. And we track consignments moving from source to destination just using drivers' feature phones. The way it is done today, it's usually called SIM tracking for people who are aware of this technology. It's simple. It uses the mobile SIMs and it uses triangulation from the cell towers to approximate the location of the driver. It's not super precise like a GPS would do. It still serves the purpose of my customer, who might be the OEM, who is trying to track the shipment of their material through a particular truck via the driver's mobile phone. Okay, feature phone. It does not use anything. The idea is every single time we try to do things. Similarly, for example, the furthering the concept of using what we have today rather than coming up with something new. We have faced the problem of, oh, these drivers even turn off that feature phone. Now, how do I track the truck that is actually going from source to destination? Because the material that is being moved in the truck is lifeline for the OEM. His life, his blood and sweat is going through that thing. So what we have done, we have integrated, let's say, fast tags. If I did not have a smartphone, I'll go with a feature phone. If I don't have a feature phone, I'll use fast tags, because whenever a truck has crossed a fast tag, we actually tap the data to be able to find out which milestone has it reached. So you can approximate to how far we can go. And over a period of time, what we have built is we have built these learning models which estimate when a driver has hit this point, when is he going to hit the next point, and what can I expect? And if he has not hit a particular destination at by an anticipated time, how do I actually reverse track and then find out how to get hold of him? So all works out only if technology comes to the people with what they have in hand, rather than push people towards technology to adopt something new. Eventually, that is a goal. And I think at some point in some hackathon, I was asked, there was a discussion as to what is the source of innovation? What propels innovation? And I think the answer that resonated with everyone was laziness. In sense that, I mean, whether you like it or not, that's what made Swiggy very popular. That's what made UPI very popular. I mean, for that matter, I don't have to get out of wherever I am doing. I don't want to get out of my lazy chair and then want to do everything. And not taking up anything new and getting the best of everything world has to offer is the source of what makes things click. And what your question actually is essentially asking that. I don't want to move from where I am, meaning adapt to anything new, but I want all the technology to be coming to me. How can we make that happen? I, as in the end user, right? Keep the user with what he's got, but give him everything with what he already has in his hand. And to a certain extent, I think I guess I'm trying to address that question in terms of saying, live with what you have, but figure out how innovation or technology, innovation can help leverage the existing technology.
Okay, I think what we heard was, I think we don't want to build it only for newer devices. We want to build solutions which is applicable to the wide population with existing technology as well.
If I might add a slightly different perspective to that, I think it's also a fact that it ties in back to the behavioral aspect that I was trying to highlight before. Just because some people do not have a smartphone doesn't mean similar people do not have smartphones. There are other people who are being tracked by that same type of technology. So the data that you're getting from those people are actually a reflection of not just themselves, but also a broader segment of the population, some of whom may or may not have access to that latest phone technology in their hands, right? So if we do this right, then the information you get from those who are being tracked, or I shouldn't use that word because it has negative connotations, right? If you're tracking someone, but the data that you're collecting from people with their permission, let's say, to get information about their movements and their patterns and so on, is also a reflection on broader segments of the society. So if we have more of the behavioral demographic information in place, we can actually extrapolate better. And in the process of delivering value to the people who do contribute the data, you're actually also benefiting people who don't directly contribute the data in. One direct example here is every toll facility that you have in the world today, only those who pay use the toll facility, for example. But it doesn't mean that those who don't pay don't get benefits, right? When you take some people off from the congested main line, and put them on a toll lane, it means you're actually reducing congestion for the other people also. So I think there's some kind of analogy that can happen here, but you do need a little bit more information about your demographics, about your population segments in order to make that leap.
Thank you, Rama. Ethan?
Yeah, I think quick question, no, going back to what Gaurav was saying. You talked about putting data and the models in a room, right? So that no one else can see what is happening. There's also the other side where we talk about interpretable ML, trust in the models, right? So in this scenario, right, where you're closeting them and keeping it away from others' gaze, right? How do you ensure you still have trust in what is being done on the data, on the models? Are there any thoughts on that already?
So I think we have to define interpretability in a more clear way. I think the reason that many of these terms like interpretability and responsible AI, we don't make progress because we have not even clearly understood or defined them. What is responsible? I seriously don't know. Like it's like, yeah, it should be responsible. We understand, we sort of get it in English, but what does it mean to be responsible? Does it mean it has to be perfect? Does it mean it can reason out? Does it mean it has to be able to explain every decision? I don't know which one of these is true. They mean very different things. So if you're asking like, see, as we sort of evolve into more interpretable models or responsible models, whatever that may mean over time, and for different use cases, different data types, it will mean different things. I think it will be inbuilt in the model itself. Sometimes we look at these as a human thing. I mean, when I sit on a plane, do I understand how it works? I have no idea. I mean, I hope it works. I mean, someone has done their job, right? I mean, I just trust the process, right? So it doesn't mean like I have to understand. Like I don't question doctor when I go to see a doctor. I don't question like show me your degree. I trust the process. So when he writes MBBS, MD, I trust the process. Someone has done their job. So here again, there is a bit of certification of models that whatever goes in, whether they are stating data, whether all that has to be done. But I think this process of training them without human gaze and without them knowingly or unknowingly stealing private information from the data can be handled. So it doesn't change anything. The challenges in those topics exist irrespective of this. It is as we make progress, I think the same models can come in this CCR beyond human gaze and do the same thing. But it will take some time. I think we have to rethink many of these models because it cannot be afterthought. It's not like you do all the sins and then you go to Haridwar and all your sins are gone. Right? It doesn't work that way. You have to rethink responsibility and interpretability as part of your foundational, building blocks of models. I think it will go through that churn. I don't think just putting it as another, okay, let's add another thing and make it responsible. I don't think it's going to work. That's why we have not seen much progress. So, but in my limited understanding, I don't think this solution is too impacted by that.
Anybody else have any comments? In I think if there are no other questions, we'll end here. I would like to hand it back to Marianne.
Thank you, sir. I take immense pleasure in thanking you all for your valuable contribution to this panel. It was sure filled with insights and expertise. I would like to call upon Mr. Ravichandran Srinivasan to felicitate our panel members and a moderator for this session. Dr. Ajay Gumala, Dr. Gaurav Agarwal, Mr. Ravi Bulusu, thank you, sir. I now request Professor Geeta Krishnan Ramadurai to deliver the vote of thanks.
So on a Friday evening so late, it's good to see still many of you here. I know there's a CSK match happening, right? You gave priority to the mobility initiative, right? Over CSK match. That means a lot. Thank you all, right? So see this mobility collaborative, the idea itself, I would say, has been cooking for a long time, right? And I would say, in fact, over 3 to 4 years. I think our alums, Ashok Krishna and a few others, they had visited us and they challenged us to think bigger, right? So we were kind of like frogs in the well, looking at our own problems, right? Looking at silos, right? I think what Ravi was also indicating about. And that got us thinking. And we started talking about it, right? Several iterations. And I think we spent a good part of last year trying to mature this idea into what it is today, right? So a lot of thanks goes to everybody who were instrumental in shaping our ideas to where we are today, right? So too many to name, but the entire alumni group, the faculty group, right, who helped this happen. I should also thank, of course, the alumni team who are actively working with us in putting this collaborator together, right? So, of course, Ramki has taken on the additional responsibility of being the CEO. So, very grateful to him that he brings so much of wisdom and expertise. I'm sure under his guidance we'll grow. And then, of course, Ravichandran Srinivasan. So, he may be age-wise the senior most, but in terms of enthusiasm, right, he is the youngest of us all. So much we can learn from him. Thank you, sir. And then, of course, Ajay and Rama. I think they must have been twins in some birth in the past. They they work so well together, right? They keep everything on track. So we're grateful for all the alumni support we got. And of course, initially we also had Swami who couldn't, he had other professional commitments, so he couldn't continue with the team. So this is a small team, right? And like Ramki said, Tana the Kutam, right? We all came together to make this happen. So thank you to the alumni group. And of course, the faculty team that we've had, right? In the transportation group, we've been discussing, at home, we do this drishti, we try to take it out. I think they should do something for that to our transportation group. We should get some really old person to come and do that. The kind of cooperation, the cohesiveness with which our group works, right? It's really, really amazing. It's enviable, right? So grateful to all my faculty colleagues in transportation and outside transportation as well in IIT Madras, right? You saw the strength. We had invited the heads of all the centers. Everybody came except my close friend Ravi, and Ravi couldn't come because he was teaching a class till 6 p.m. and he had a flight which he had to leave from here at 6:30. So he was asking me, shall I come in between that time? I said, Ravi, I never know how long it's going to take, right? It's fine. You can focus on but the strength was here to see, right? So it was great. The deans, the directors, they've all been very supportive. So I'm grateful to all the faculty and, the deans and directors. Then there's a lot of work that happens in the background, right? So the entire setup for the conference, making the arrangements, sending the emails, editing the presentations, right, till the last minute, right? So that credit goes to our staff and team, right? I'm just naming a few of them here in case I miss out somebody. Excuse me, but you've all been supportive. Nivashini, if you can stand up, and Ritesh, Rokom, Swali, Adarsh, Lakshmi, Rekha, Vijayaraj, uh, Anish, Fatima, then Abhirami, Satish, Chitra, Satvika, Siddharth, right? You all made this happen. Thank you so much for all the efforts that you've put in. I'm sure if you've been in IIT Madras for a long time, you would have seen the level of professionalism of these conferences have kept going, higher and higher, right? I take the credit for it. Not at all, right? The only reason this has happened is because we have a fantastic professional team, right? So we have the team from alumni and corporate relations, here, Miriam, Aishwarya, and ma'am also. Surya Varshini ma'am as well, right? So, and there are others as well, right? In the alumni and corporate relations team, I think they are setting the bar really, really high, right? And I just hope, we keep getting your support, right? I mean, it is just fantastic the way, the whole thing unfolded, right? Um, of course, we also had the team from NPTEL, Karthik and team, right? As well as the conferences team from Global Engagement, Mary and team, right? So they, again, all the online setup and everything they've done, right? It's now like, you talked about mobility as a service, right? Now I think we can offer conference as a service, right? We have the entire team, everything streamlined. So I'm grateful to all of them, right? Last but not the least, right, you would have seen the stunning visuals throughout this, event, right? And these were created by our own alum. So we talked about, talent is all there, and right, we don't get to see. And so, Monish is our alum. I think he had to leave earlier today, but he's not here. But his team is the brain behind, the logo, the color themes, right? All the flyers that we put out and so on, right? And I think there's a lot to learn, right, from that team as well. How visually you can really, get people's attention, right, and then get more participation, right, get more appreciation. So I'm thankful to them, right? This is a collaborative. This will not succeed without the support of all the founding partners, right? It's been fantastic, the extra mile the founding partners have gone to make this happen, right? We have ZF, we have Yumi Enders, right, and several others who've joined online, PKF, right, Zera, on mobile, right? Every one of them, right, has been Sintra, Interrise, right? So every one of them has been very supportive, and with such a founding team, I'm sure we'll go places, right? So we are ever grateful, to all the support we are getting, right? And eventually, we're supporting the government, right? And the support we are getting back from the government is also phenomenal. We saw that with the DOT secretary himself setting aside time in his busy schedule. We saw the joint secretary of DPIIT as well, right? Personally coming and chairing that session wonderfully, right? And already, we are having multiple conversations with the deputy secretaries in DPIIT how to take this forward, right? And several other ministries as well, Kumta in the state government, right? So support from them is also great, right? So with all the support, I have very little doubt about our success, right? It's just something that's bound to happen. And I'm grateful for all that support. So thank you all so much. The audience, of course, make the event. So thank you all for joining. And we'll make this an annual event, and we'll keep making this better, grander, right, every year. Thank you very much.
Thank you, Professor. We would like to extend a heartfelt thanks to everyone present here and those who have joined virtually. Your presence truly made a difference and contributed to the event's success. Your involvement is greatly acknowledged and appreciated. I request you all to please come on stage for a group photograph. Post this, we have arranged for dinner at the main dining outside this hall. Thank you.
Can those who are online also turn on their cameras, and can we have the Zoom participants in the projection here so we can get them also in the group photograph? The Zoom online participants as well, if we can get them their videos on. You should do that. Okay, yeah. Please come up on stage. We'll have a quick photograph, and then we will break for dinner. Those who are online, if you all could turn your pictures on, that'll be helpful. Thank you.